So Hadoop is, which is what people refer as data lakes. Deep down, they are Hadoop applications, right? They're very complex. You can support variety of data, but they're very complex to manage. Like you need to manage those huge clusters, which runs like basic hardware. It's not that very basic. They're still like 64 core 512 MB machines with 8 to 10 disks. But as for the marketed as commodity hardware, they're like not very commodity by the way. But yeah, still not very specialized like data warehouses, right? So uh, the data quality, like in a warehouse, what happens is that you cleanse your data and then only you load it there. You give it a structure and then load it there. Whereas in Hadoop or data lake, it was the other way. Like you land your raw data and then you transform it and then present it for whatever purpose you wanted to do it, right? This whole thing was very expensive. The data quality is not that great. And unless you are a LinkedIn or Uber kind of team who understands this in and out, they were able to manage this. But an Amex cannot because they are not like LinkedIn or Uber or Flipkarts, like deep engineering teams, right? Around, I should say, 2010 or rather 14, 15 time frame, a lot of cloud guys also came up with warehouses. And there was a wave around separation of compute and storage. Because with Hadoop, there was this problem that you want more compute, you add a node, and you get more storage. So you don't need storage, and the vice versa. To get storage, you have to add a compute node, which makes compute which you don't need. So that way, a lot of vendors on cloud like AWS, I don't know if Azure also had its insights. So they started, even IBM had one Hadoop offering on cloud. They started with this new concept of separation of storage and compute and have warehouses where your storage is object store based and then you have computes. They, they just address some of the problems, but they were still very, like you would say you have vendor lock-in, and since they were warehouses, they couldn't solve the AI/ML kind of use cases. They still continue serving structured data and all, right? So then around 1890 timeframe, and like a new data management pattern came into existence called data lake houses, and for that. Yeah. So data like lakehouse is nothing but what has happened is it's nothing but best of both the worlds. Like think of like if somebody had to do a data warehouse in 1890, he could have done the middle thing, which is like take the best of both the things. And this pattern people started using in their enterprises, and then somebody wrote it out as okay, this pattern is called data lakehouse, which is nothing but best of both the worlds. So it supports both the use cases, like warehouses shine at BI reports, data lake shine at data science AML use cases. So lakehouse actually serves both. Uh, in a lakehouse, you can do ETL and load the data, or you can load raw data and then do ETL on that and bring structure. Warehouses were very costly, whereas data lakes were cheap. Data lakehouse can be as cheap as data lake, but still gives you a lot of other benefits. Warehouses are like proprietary in terms of data format. So if you store your data, let's say in a warehouse, you can consume that data only through that engine and not any other engine. So you are kind of locked in. It was not the case with data lake, but it was difficult to manage. So lake houses typically use open formats. So it doesn't matter whether you use an IBM lake house or a database lake house. If your data in open format, any engine can read it, as long as that engine supports it. Right? So you're not logged in any engine, right? Data warehouses had a scale issue in terms like they can scale only at a certain level and they become very expensive. You can scale them, but they become very expensive, whereas data lakes could scale, but not that easy to maintain. but lake houses can scale and are decently okay to maintain. They support both the use cases, and with lake houses, the lakes, the performance was not that great. But with lake houses, we can have multiple engines purpose built for something, and I'll come to that point. Like WatsonX.data has two engines. One is Presto, other one is Apache Spark. So if you are doing BI reporting, Presto is a good fit for you. Because it is very interactive. You fire a query, you get the result. It is an analytics engine which runs constantly and caches things so that your next query becomes more faster, right? So that way, if you are a BI reporting guy who want quick results out of your query or reports, you can use in a lakehouse of Presto engine. But if you want to run a long data transformation job, you can write that in Spark program and submit that as a batch application, which was not possible in warehouse because it had only queries. There was transformation has to be done outside through some ETL tool, right? Data lake lacked a Presto kind of engine, so it was not good for interactive things. Like there were open sources which were built on that, and Presto is an outcome of that thing only. Okay, so that way, another thing is the storage for warehouses was local storage or block devices. They're very costly, but for lake houses, it can be like typically it is an object store based, which is dirt cheap, right? Yeah, so like lake houses are there. Why another lake house or WatsonX.data? Like why I even thought to build that, right? So the existing warehouses has problem. Like the thing is, some of them run on cloud only, some of them are software only. But when you go to enterprise, they need same interface which can work on cloud and in their own data centers, right? Which is not possible with whatever lake houses are there today in market. Like if you take Databricks, you can't have a Databricks in your own data center. It has to be on AWS or Azure, right? Similarly, the existing lakehouse, the first generation guys, existing lakehouse, right? They don't still support multiple engines. So that way they excel at one thing or the other, right? And they typically come up with their own governance thing, like where you store metadata and storage data that who can access what, right? Versus picking up into an existing governance, because any data company already has all this. What you need is a system which can hook it up to that, right? So I have my policies defined somewhere, and I should be able to apply the same policies to my lakehouse also, right? Which is what was lagging, and which is what WatsonX.data provides. Like it is the first data lakehouse implementation which is completely open source, no vendor locking, because the data is stored in open formats. Almost all the open source, famous open formats are supported, and the governance here can hook up with a lot of existing governance things, right? So this is how like this picture actually represents WatsonX.data in the best way. So if you see at the bottom of it, like any software is infrastructure, right? So you can, as I told earlier, right? What you need is when you're building your data strategy, right? You need something which can run. Like it should not be like I'll be there only on cloud, can go on data center, my own data center, right? That software should be able to run there anywhere, and which is what WatsonX.data provides. Like you can install WatsonX.data on a Red Hat OpenShift cluster. Doesn't matter where it is. It's on your laptop or it's on your data center. in AWS, Azure, Google, everywhere you have OpenShift clusters, and you can install .data there. So that way, there's no limitation like I'll run here, but I'll not run there. When you're coming up with your strategy, you need flexibility, which is what this provides. We also have managed service. So one is like you buy our software, WatsonX.data software, and then you install on your clusters and maintain that. The other one is WatsonX.data as a service. We're there on IBM Cloud and AWS. You can go to IBM Cloud and provision a WatsonX.data, a lake house for yourself in 15 to 20 minutes. Okay. You can provision a trial lake house for yourself in under 3 minutes. So think of you could create a lake house which is so many things under 3 minutes, and you can run a trial experience, and within an hour you have a decent idea what this can do, right? So we have managed lakehouse on IBM Cloud and AWS, but as a software, you can install it anywhere you can have OpenShift, right? The storage, like it's a lakehouse, and it's a data thing. So you have to store data in whatever format you like. It is Iceberg, Delta, Woody, Parquet, Avro, whatever data formats, it has to be stored somewhere. There has to be a disk to store that, right? So we support all cloud object stores. It may be IBM PaaS, Amazon S3, Google, ADLS on Azure. Everything is supported. We have a meta store and a governance layer to like when you're dealing with data, you would like to catalog that because you will consume them as select start from a catalog, a table, a schema, a table, right? You need to catalog that data. Right. Okay, I have these Parquet files, which I want to query with this catalog schema. So basically, that's where the meta store comes into the picture, right? So we have a meta store which supports, like it's our homegrown meta store, but it supports all the open APIs. It supports the most famous one is HMS. Not sure if you guys have heard. Like folks who are from Hadoop world would be knowing that HMS is an industry standard, like high meta store format, which Presto, Spark, and earlier days Ping and many other things were supporting, right? We also support hello, yeah. So so this meta store also exposes like last year Databricks announced Unity catalog and Unity APIs. So we started supporting that interface also. So let's say you are a Databricks, but your data is somewhere in WatsonX.data. You can still work with that data because you support Unity catalog interface, right? We also support Iceberg REST interface. So you can consume your metadata on REST from any application running anywhere. It's not just our agency. Data formats I talked about, like they support all three famous industry table formats, Iceberg, Delta, and Woody, and all famous industry formats like Parquet, Avro, ORC. So it's all supported. At the top of all that, right, are the query engines or engines. So as of now, we support, I would say, 3 kind of engines for BI use cases and reporting, Presto. We have 2 flavors of Presto, and I think there is a talk about that today. Presto and Presto C++. So Presto is written in Java, and hence it has inherent drawbacks. So we also have Presto C++. It's there in the product, which since it is in C++, is fast and it's good at doing certain things. So Presto C++, I think my colleague will talk later in the day. We have Apache Spark, which that is like, and people will be talking about it. So, and Apache Spark also, like Apache Spark is written in Java, and since it's in Java, there are certain operations which Java is not great at dealing with many objects, and the scale at which Spark create objects is massive, and doing IOs. So in 2 months from now, there's a release of WatsonX.data, which will have a variation of Spark or gluten. So gluten is, think of that as Spark with a layer of it written into C++. The one which do relational operation and the one which do IO with is written in C++. So you get the goodness of Java that it can run anywhere, but at the same time, the speed of native code like C++, which are fast. So that's coming. That's not in the product today, but that's coming. We also, like, since it's a lake house, and lake house are like, it has to serve like data for AI and ML use cases also. So we also have its data. Like even what is coming through AI is data. So we have a vector DB store called Milvus, and this is where you can store your embeddings and retrieve that. And like a lot of IB products use this under the hood to do RAG and manage AI use cases. Okay. So essentially, this is like WatsonX.data. It's an open lakehouse. Presto is open source. Spark is open source. We ship 100% open source code. So if you're running on WatsonX.data, you return a Spark code. That code, if you take to any base which supports open source Spark, should just work without any code change. It's not that we have our vendor bits for that. Like we have our vendor bits, but those are extensions for optimization, which my colleague will talk about. But they're not logged in. Like they're not saying that the Spark code which runs on .data will not run somewhere else. Or somewhere else, if you have written Spark code, that will not run on .data. It should work as long as it doesn't have the vendor bits. Okay. So that's about WatsonX.data. Now let's shift the gear and like I want to talk about like share my experience. It's not just me who was building this. There's a huge team of how to go about building data systems or systems which churn out these data systems. So WatsonX.data as a service is a system which helps you provision many lake houses on many cloud regions on many clouds, right? So just to give an idea of like what we do is WatsonX.data as a service is right now available on IBM Cloud in 7 regions and on AWS also in 7 regions. So essentially, you have a system running in 14 regions, which with few clicks can create you a lake house. Essentially, Metastore, authentication governance layer, a Presto, a Spark, and a Metavers, and all of that running on Kubernetes. Now think of that. If in each of the regions you have think of now in each of this region, if you have 500 active lake houses, so 14 cross 500 is 7,000. So it's a system which is creating and managing 7,000 lake houses. A lot of data companies just run 2-3 lake houses in their organization, and that itself is pretty daunting. So I want to share some considerations when you want to build such system which can create, and I'm talking in context of lakehouse, but it applies to any data system or any system which is bringing up workloads. It can be ML workloads, it can be any workload based on a user request. Like somebody clicks a REST, clicks something on the UI or makes a REST API call to satisfy that request or job. Bunch of calls come on some queue cluster as their work and go away. Right? If you want to build that system at a massive scale, few considerations which I've learned. So there's more of I want to share that with you guys. Okay. So first thing which you should think about is scale. So like when you're building a system of the size which I just talked about, you have to think beyond a single queue cluster. Like in some of our regions, we have a K8SUG cluster, and then we have like 8 to 9 database. On our busiest region, we have 8 to 9 queue clusters, and some of them have 500 to 600 nodes. Right. So, like obvious question is like, why add more nodes to one cluster? We want to add more cluster. So, a queue cluster, though, whatever documentation and talks say, practically after 600 nodes, you will start seeing it misbehaving. So, the HCD of the queue cluster starts misbehaving. And if you are dynamically creating many pods, many services, many country paths and secrets, you will start seeing alias in country getting created. You will start seeing your pods coming after delay, not coming, started misbehaving, your DNS misbehaving. So essentially, for all practical purpose, right, 500 to 600 node is what I've observed on Azure, sorry, on AWS and IBM Cloud. That if you have a system which goes beyond 500, 600 nodes, time to build another cluster. So essentially, now as soon as you have more than one cluster where you can run your next workload, comes where should I run the next workload, right? So you have to consider that. And keep a next Spark application to run, keep a next Presto engine to create, keep a next Milvus to create. What's the best place to land that Presto Spark Milvus? Deep down Kubernetes workload, deep down deployment simple sets with replicas where I should land. Deep down Spark cluster or Presto cluster is nothing but deployments with replicas, happy maps, secrets, NLVs, ALVs. That's it, right? So when you have more than one cluster, how to land, how to decide where to land, right? Choice of storage is also very important. Like a lot of people have seen the state storage is persistent volumes. That's not the case. There are many storage solutions of Kubernetes, and you have to use losses for the courses. Like if you're dealing with persistent data, then only go for persistent because using them has many drawbacks. And when we talk about Spark, people will go in depth about that. Okay. Since you're dealing with a massive system, cost becomes very critical. Like you can't just bring up nodes and for every house and burn money, right? It has to be cost effective. So the consideration which you should have is scope of multi-tenancy wherever possible in your whole system, right? If you have a service, let's say metadata service, can it be multi-tenant? For every lakehouse, instead of creating a metadata service, can I share the metadata among many lakehouses, right? The metadata is backed by a database. Can I share the same database, right? Versus every lakehouse providing its own service and a database which is not cost effective, right? I should not be like landing a Spark cluster or a Presto cluster on a different node. Like, there are cases where it is really required. But then if you're dealing with trials, the lifetime which I talked about, right? We want to bring that in 3 minutes. So how would we do that, right? Like we can't go to a cloud and provision and node in 3 minutes and add it to a group cluster. That's a 10 minutes process, right? So, and trials are like tiny things. Like a trial Presto cluster would be not more than 4 GB. It's just a pod. It doesn't even have to be a cluster. A Presto can run in one pod. Trial Spark application can also be like rather an executor of 1.4 GB, nothing beyond or 1.2 GB. Right? So you don't really need to bring up a node for that. So when you're considering that system, wherever you are, there will be needs for trials, there will be need for smaller t-shirt sizes, and hence think about multi-tenancy. Like have pool of nodes in your queue cluster and land pods there. Make them auto scaling so that as and when a pod comes, the auto scaler adds more infra or shrinks it, right? This also helps in another way, and it leads to the first point. If I add too many small nodes to a cluster, right, and a cluster can't go interrupt. You want 500 to 600 nodes. It's up to me if I add 32 core nodes to that cluster and get per cluster 32 cross 500 or 600 cores, or if I add 60 core, 32 core, or 60 core, or 4 core, 8 core machines to that cluster, because the limit is 500 to 600. Doesn't matter how big or small is that node, right? So that way also, for you to not bring up another queue cluster and maintain that, because a queue cluster coming around, even though it's on a cloud provider, does require maintenance. And every now and then you have to replace workers for security. That's the basic thing, right? And it's not every now and then. Once in a month, typically we do, right? So that way, having multi-tenant nodes helps. Kubernetes provides mechanism of passive isolation. You can have namespaces, passive isolation. You can lock down inbound, outbound with network policies, and you can have isolation. So there's no need per se to bring up separate nodes, right? Every node that you bring on Kubernetes, right? And when you're building data systems, you're talking thousands of nodes. When you bring up a queue node, right, you pay a tax to Kubernetes. Kubernetes runs few demands of that. And over that, it does like OpenShift will run some more pods there. All those pods eat up into a 32-core machine and a 128 GB machine. They eat up memory and CPU. So what I've observed is typically across vendors, 10% of your machine goes towards queue tax. So if you have many small nodes or in your cluster, you are wasting a lot of hardware, which you're not giving value to your customers, but at the same time you're paying for that. Right? So that way, it's another reason to have beefier nodes wherever possible, because and those beefier nodes should be used in a multi-tenant, right? This is a big learning which I have. Other thing is when you're doing a system like this, right? You can't think of like it will run only on a certain kind of like EKS cluster or EKS cluster only. You need to think about you have to go multi-cloud, how you go about going into any key distribution and any VPC. And so essentially, the way security works, that the way security thing works is that even though it's a Kubernetes pod, the configurations, there are certain changes in configuration when you run a pod on EKS versus OpenShift cluster, right? So when you design your operator or your Helm charts, it has to be parameterized. Like, am I running on an OpenShift cluster and hence I should render my YAMLs in a certain way, or my operator should render make a Kubernetes SDK call in a certain way, because that's what the underlying cluster means. So keep that in mind. Like that's very important. You can't assume that you'll be running only on a certain K8S cluster. Another thing is VPC. Like, don't assume that you can always go to a kube cluster and do things. If it is a customer VPC, which would be the case for a lot of data systems, because customers don't want their data to be accessed by compute which is in their network boundaries and not in any other place, right? So when you're doing this, keep in mind that you don't like assume that I always have an access to a Presto or a Spark. That's not going to be the case. A Presto and Spark should let you know that I'm around and I'm of a certain shape and size so that you can monitor that whatever your provision, like if you have 7,000 resources running, you need to monitor that. How is the Presto cluster number 3023 doing, right? Am I getting hard rates from them? Am I getting like a Spark running on cluster number 4070 is auto scaling? Basically, when it is running an application, it goes up and down. Am I getting enough matrix to build it appropriately, right? So you can't go to the cluster to this Presto or Spark or any data thing to know that how you're doing. It is these guys who have to tell you how am I doing and how big was small I am, or any information which your business needs. Like for me, context of this, these two information was very critical. One is am I healthy? And the other one is how big or small I am. Right? What I'm doing right now, that's another thing. I'm running an application or I'm sitting idle and so on. Right? When you're doing large systems, think of them as independent components, often known as microservice. And think because you can't deploy such massive systems like Lakehouse, and on all 7,000 places, I would say that okay, I have a new version of Presto, let me handle it. I have a new version of Presto and some Spark and maybe some fixes, and I want to apply them. You need to break that into things, like a Presto microservice or a Spark microservice, and then deploy them, or a metadata microservice. And when you do that, and you deploy Presto, Spark, and metadata, and there was parallelly or at a different cycle, you need to make sure that they are always backward compatible. Right? Presto, when talking to metadata, if metadata goes up, it should continue to talk to metadata, and not that I can't because metadata is the same messages. Right? So it has to be backward compatible. So to deploy such massive systems, you have to break the system. When you break the system, make sure that they are backward compatible. The other thing is deployments. You can't push things to these guys. That's not gonna scale. Right? So as for the hardware thing, right? You can't go and pull things. It has to be a pull or push model. So what we do is we use Argo CD to apply things, and we use hardware mechanisms to stay straight with them. Right? So yeah, these are some of the considerations which like you should have when you are doing a data system. And yeah, there is sorry for the font, but there's a canonical architecture of one such system, like a system, and I'll just talk about few bits here, in interest of time. So one thing is like you see here, right? We have something called deployment service, and then you have engine services. So like when I have to land an Presto or an Spark, I go to this workload dispatcher, which helps me in answering that question which I talked about in the previous slide. And I have many data planes where I shall land the next Presto cluster here, or here, right? So it is this guy who decides, and the way it decides is to it maintains that on this cluster I can have these many small Prestos, these many large middlewares, and all that information comes in an like through heartbeats by a guy called data plane agent, right? So on each cluster we have few of our bits running, like basically these data plane services, and these data plane services are the ones which helps us in many ways to say that a particular queue, a data plane is nothing but a queue cluster here. A queue cluster is alive, and if yes, what capacity it has. Like if this guy is sending heartbeats often to the control plane to say that I can host another 100 plus two clusters, small, medium, large, I can land these many Spark applications. So like the consideration which I talked about that you need many clusters, and now if you have many clusters, how to land your next workload? One way to achieve that is like each of the clusters saying that how much capacity I have, and then accordingly your control can decide where the next workload should land. Right? So again, as I told, don't assume that you can hit left to right, because this a lot of time these things are in customers VPC, which are locked. These are data systems, right? So the communication should always be right to left. In this case, if each of these guys should look for, do I have something to do, right? So let's say if I want to land next Spark, and this guy decides that you should land here. So there is no API call or a network call going here that land a Spark here. What's happening here is this guy sends a message on a messaging bus that there is a workload that needs to be deployed on data plane 2 on our cluster. And it is the deploy here, which is constantly listening for work. And as soon as it says that, okay, there is a work for me, which is nothing but to bring up the Spark, it will send it. So essentially, the point which I was talking about, right? You can be in any VPC, you're allowed to go in, or maybe not allowed to go in, but you still have to do things here. And the way you can achieve that is through a messaging system where you can plan the workload, saying that this workload should run on a certain place, and systems like RabbitMQ and Kafka give you this capability to have routing key, multi keys, and based on that you can add the workload setting. I also have Argo there, which helps us in like syncing up if there is a new version of data being agent or a cluster autoscaler, or if there are more agents, are just make the diagrams correct. So it is an Argo thing which pulls the changes. So again, it's a pull. Like I can't from here push changes here. It's not on a scale. So it is all pull. So I'll stop here and I'll hand over to Deepa. She'll now talk about the Spark things. Speak to me later or yeah.
Hi everyone, I'm Deepa. So I guess most of you already know about Spark, but just a brief introduction. So it's a general purpose distributed data processing system. That's an engine. One of the engines that Dharmesh was talking about, which is available on WatsonX.data. By general purpose or unified, it supports various kind of operations. Be it machine learning jobs, data science jobs, data processing, streaming, batch application, ingestion, query, all of this is supported by Spark. That's its ability, and that's why it's famous. There are a lot of industry standard Spark is what everybody uses. Now coming to distributed, because it is distributed, that's how you get the parallelism and the fault tolerance. So give a brief of how Spark works. So you can consider this as a master slave architecture, wherein the master is the one of the pods. You can consider master as one of the pods, which has the Spark context, the driver program, and the master. All of this is running in one of the pods. That's the master. Then there is the cluster manager, as the name suggests, manager who actually takes care of allocation, task management, all these things. So cluster management takes care of that. Then there is the worker nodes. There can be multiple worker nodes. These worker nodes is what brings in the distribution or the parallelism. Each worker is where the actual work takes place. The actual developers, you can think of. This is the manager, and that's the actual developers. So developer can be doing multiple tasks. So as the workers. So each worker has one executor process, and each executor, based on its ability, the number of cores that it can run, those many number of tasks that it handle. So this is what brings in the parallelism. And this is what gives the speed to Spark. It's fault tolerant because the RBDs are immutable. Whether the worker goes down, comes back up, Spark can handle it. It has the directed acyclic graph, which maintains the history, who did what. And finally, it can reassign the task from that point in time. With all these distributed processing and parallelism, that's how the Spark engine has more traction. So if you ask where did you guys start your Spark journey, it's way long back. That's in 2014. That's HTTP, which we were running at that point in time. HTTP is WatsonX.data platform. So now it's taken over by Cloudera. WatsonX.data platform, you can think of it as a mammoth. It's not even an elephant, bigger than that. It has all possible services. It's a stack that they provide. and that has, you name it, and all big data sets, Hive, Big, HMS, Spark, Hadoop, HDFS, everything. So that entire stack is what we used to provision it in 2014. There were good amount of customers who used to use that. But you cannot handle all these services on pods. And at that point in time, K8 was not even born. So that's when it was all provisioned on VMs. So when it comes to VMs, it's obvious. Lot of cost involved, maintenance involved, time consumed, bringing up all these services on VMs at a large scale, it used to take a lot of time. It had its own pros as well as cons. Then that's when Spark came into picture and it had a lot of traction. It was good. It was better in processing, faster, and in memory. So that's when we moved in 2017 towards Spark. When we moved to Spark, we also made a change. And that change was we separated out the compute and the storage. So by that, I mean Spark takes care of the compute, where the processing happens or the actual work happens is Spark. But then there is the data section or the storage. So if you club both of them together, you need to have everything at scale. You need to scale everything. That's more troublesome, more tedious. Rather, we had the storage separated out. You can bring your data from anywhere you want. Keep it separate. HDFS, S3, COS, ADLS, GCS, any storage. It stays there. It grows. You can shrink whatever you want. Nothing affects the compute. Spark takes care of the compute part. So that's one separation we did. Few years down the line, we then moved to the containerization. Docker came into picture. So further reduction of cost, that's what innovation is all about. Faster speed and reduction of cost. So Docker containers came into picture. Another wrapper on top of VM where we could run all these workloads on containers. Each VM was hosting multiple containers. So now, instead of one executor, the worker model that I was saying about Spark, one worker is to one VM. We have multiple workers in single VM. Faster processing. Then in 2019, K8 came into picture. So we thought further optimization, another layer of wrapper on top of containerization, that's Kubernetes, which manages the entire service, lesser work for us. So that's where the serverless Spark came into picture. With serverless, we have we don't have to worry about what's going on in the back. Not the cluster. Is the VM up and running? What do we do with the VM? What do we do with the storage? Okay, it's all readily available. On top of it, all we do is deployments of Spark. So we care only about Spark's workloads, Spark cluster, actual running of applications. Then we remodeled it, improvised it with entry-dir and equivalent storages. I'll talk about it in the upcoming slides. So that's what the remodel in 2021 was. And the same architecture is what we have ported in 2024 to WatsonX.data, which Dharmesh just now spoke about. That's the engine support that you get in WXT. Main features or main points or philosophy, you can call it whatever you want. Few of the key points about our Spark service, a Spark engine is, as I said, either the customer or we have to worry about bringing up the cluster, bringing up the VM. There's no lock in there. And when you bring up the VM, you have to keep them warm, snapshot it, keep it available, ready. Otherwise, it becomes the same old story with continuous data network, where bringing up the entire mammoth, all the services up and running, takes a lot of time. The patience level is reducing day by day. You cannot make the customer wait long enough to bring all the VMs and the clusters. So that's where the pods are brought in within seconds, not even seconds, I would say milliseconds. So we concentrate only on Spark workloads, which can be application, ingestion, CDC, even kernels, notebooks, any of these things. All of them run on pods. And these pods, as you all are aware of, it's based on image. And this image is pre-pulled on the Kubernetes nodes. So it hardly takes any time to bring up a deployment or bring up a pod using the images that are already pre-pulled or already available on the node. That's how the workload starts in seconds. So by being enterprise ready, we have lot of certifications. Each customer comes with their own requirements, multiple scans, multiple security certifications. We have to get it certified and only then will they accept it. So all these certifications are done consistently on all our offerings. Even in WatsonX.data, all the engines, Presto, Spark, everything. So we support 100% open source, which I think Dharmesh was saying. There's no vendor lock-in. By that we mean the same workload that you run, same application that you write on our Spark can be run on open source Spark. In the same way, if there is no extra bits that you've added, whether you run it on Databricks or on open source Spark, the same thing can be ported onto our Spark. It's 100% open source. We support all the features that open source supports, whether it is Spark UI, Spark history, all the various language supports that Spark provides, Scala, Java, R, Python. You can write it in any format you want, any language you could use to write your application code. Coming to connectors, we have a wide range of connectors. S3, COS is IBM Object Store, ADLS, GCS, all the storage formats are supported with the Spark offering that we provide. It's all built in, pre-built into the image, and all these connectors are available. You don't have to make any customizations or improvements. Now coming to the Python and R packages. So for the machine learning and the AI models that you want to build, there are a lot of packages that data scientists would need. Most of these used or required packages, all these packages are already pre-built into the image. So you don't have to bring them in, it's readily available. You could just start using it and build your models. So by customization, we have support for multiple Spark versions. Right now, we support 3 versions, 3.3, 3.4, 3.5. Spark 4 is almost there. In a month or so, it will come in. So we start supporting Spark 4 as well. So this is what differentiates it from open source, wherein you can pick the version that you want of Spark and you could run your applications accordingly. And this specified version is not something that you have to think way before, even before like bringing up your instance or bringing up your lakehouse. You could think of it just before submitting the application. In your payload, you can specify what version exactly you're looking for, and you can change the version of Spark. There are various configuration or tunings that you want to do around Spark. It could be around memory, it could be cores, it could be resources, or compression, spill strategy, multiple things happen in Spark. It's the big data processing. So there are a lot of tunings that Spark provides, and all these tunings can be done through configurations or environment variables. Again, this is as simple as passing it in the payload. You don't have to think through it way before. Just before submitting the application, or even in your notebook, you could take this to improve the performance of your application. The Python and R packages, you could customize. So you say maybe you have few packages, but I want to bring my own package. How do I do that? Yes, there's provision for that as well. You have your package, say in S3 or any of the object store. All you have to do is in your payload, you can say this is where my package is, bring it in and plug it into your image. I want it available even before Spark starts. Yes, that's possible. You can just add it in your payload, in the application payload, and it brings in the jar or any package, or even from a event record for that matter. You can bring it from anywhere. And that's available on the image. So bring your own container image is another new feature that we're bringing in. That should be available in the upcoming release. Okay, so yeah, maybe let me speed it up a bit. This feature will allow you on the existing image, you can add your own packages and you can say, I want to customize my image and I want your Spark, your deployments to run on my image. That is the ability that's going to come in future. These three are the main enhanced features when compared to open source pack. Auto scaling is one of our research asset. It comes from our IBM research labs. The speciality of this is, I think Dharmesh was speaking, the data the data processing happens on worker pods, right? These worker pods can be dynamically allocated. It can scale up or scale down. And along with the shuffle management. So the Spark has shuffle data. There is data processing on each worker going on, and that data has to move it. It has to shuffle between these workers. And that is also handled along with the auto scaling. Then comes the logging and monitoring support, which at enterprise level or at this scale, when you have to be production scale offering, logging and monitoring is ought to be present. So we provide a good amount of monitoring support as well. The disaggregated shuffle is another research asset that we have, wherein the shuffle data that I just mentioned, shuffling that Spark does, the data need not be moving around between the workers. You could specify a specific object store or a volume, an NVMe drive for that matter, and the data will shuffle within that. This gives a huge improvement in speed. The performance improves a lot because the shuffling is happening locally. All the workers talk to the same storage. A brief about the architecture. So you can consider Watson Studio and Watson Machine Learning, WML and WS. They both are our clients. They make a call. You could say HTTPS call, whether it is an application or kernel. The load balancer takes care of on which the data plane is supposed to land and which replica it is supposed to land. There are multiple microservices in the control plane which handles all this flow, and the load balancer takes care of the load balancing. And in the control plane, the decision is made or the blueprint is created as to what kind of a Helm deployment has to happen. What are the needs for the config paths, the secrets, the volume mounts, all these details are fed into a blueprint, and this blueprint is sent across over to the data plane, and the Helm deployment happens. And that's where the Spark pods come up. The Helm deployment is what takes care of many of the Spark pods. We provide multi-zone support. So one of the availability zones is the deployment is. As I was saying, there are two kinds of workloads in Spark. One is, it is based on the manager. One is the standalone cluster manager. The other is the Mira cluster manager. Mira is nothing but the auto scale piece, which is the research asset that I was talking about. So the standalone cluster manager is like another service that is running inside the master pod. That's the master pod, which has master process, driver process, and the cluster manager. In case of Mira, the cluster manager is separated out because it talks to the master and takes care of allocation. So the main difference is that in a standalone cluster manager, you need to bring up all these workers prior. You need to decide the team size upfront. Only these developers are going to work. And if those developers go down or they are not going to work, then the data has to be shuffled among them. You cannot bring in new workers. So that's how standalone cluster manager works. Coming to Mira, it has the flexibility wherein it can scale up and scale down. You could set the minimum and maximum number of pods that you want to do the scaling between. If there are few workers and there are few tasks, it will suffice, it will work. There are more tasks or your application is demanding more such processing. It can scale up and take care of the application processing and scale down when it's idle. The other important point that you want to note down is the empty depth. So this is something which is ephemeral in nature, wherein if you keep the volume mount for on persistent storages or PVCs, they're not scalable. Not when you are supposed to bring up like thousands of pods, it's not scalable. Rather, if you have an empty disk with local storage and it stays only in the pod's life cycle, you don't have to bring up a persistent storage for that. And this empty disk can be mounted on an NVMe, non-volatile storage, which is very fast in nature. So that way, you could just mount it on the bare kubelet pods path, and this is very fast. And it need not stay after the pod is gone. It's only the life cycle of the pod. So this helps us a lot, and it speeds up the processing as well. So few of the key learnings. One is the people of images, which I will say. If you have the images, the Spark image sizes are pretty huge. We are pre-baking all the packages and whatnot. So it's pretty huge. If we keep these images pre-pulled already, then it can save a good amount of time. That's one of the main learnings. Second is, you cannot always rely on QDNS. When there are thousands of pods, all of them start hitting the same QDNS for name server mapping, it goes down. Or the response is very slow, we cannot cater to all the pods. Rather, we have a proxy set up in between, and this core DNS, for example, in case of Mira, with each cluster manager, we have core DNS. So Mira doesn't go outside the core DNS, it just talks in between. With core DNS, it figures out who are my workers, who's my master, and I don't need to know others. There is isolation. So it fixes its DNS within that boundary. This speeds up. The other one, as I said about the empty ephemeral storage, this brings in good performance. So K8s, when running at scale, injects a lot of variables from other services. There are a lot of pods running and services running. The variables are injected from one service to the other, and when thousands of pods are there, thousands of variables get injected. So you need to make sure that such injection and keep the isolation also in place, and they don't get injected. So that drops down the performance. And last one is machines can be bad. Obviously, when there are thousands of nodes coming up, and there are few machines which are ought to be bad. You need to have a monitoring in place, a mechanism in place where you have to find out whether we are getting good machines. So by good machines, I mean the pods might come up, the workload might land there, but the networking might be bad. It might not have the outbound connectivity or inbound connectivity, or the pods cannot communicate among themselves. There has to be some mechanism. We have monitoring and alerting in place, which takes care or tells us whether these nodes are really good, whether we should land our workload on these nodes or bring up our pods on these nodes or not. So these are the few key points maybe that would help. Thank you.
Here's a round of applause for Dharmesh and Deepashree. I'd like to call our second keynote speaker, Arun KG, Senior Solution Architect at GitLab.
Thank you. How are you feeling so far? So good? Okay. So I thought I knew Kubernetes, but I still think 80% need to learn. So I cannot update Kubernetes in my resume now. Let me share my screen. Hopefully we will see this. That's it. No. Okay. And then there is some lag. Okay, hopefully I'll be able to. Okay, so thanks. Okay, my name is Arun. I have a solution architect team in GitLab. Hopefully the last row can hear me. All good? Even if it is fine. If you're not hearing, also it's fine. Just saying many things are the nice things are the right. So the topic that we are going to discuss, as always, along with the current nature AI. Everybody talks about AI, so I'm also going to discuss AI. But wanted to introduce you to some of the new things that GitLab from a DevOps perspective, how we are leveraging AI. It will be a little bit tricky, but bear with me. I think those are those right? So bear with me. So the idea is to introduce you to the concept of how AI from the code generation can Right? There are multiple places where AI can help you. Okay. So I'm a bit tired because past few weeks I've been traveling because this is my quarter. So hopefully you're not tired as well. So few information here. I'm little bit secret. Don't take a screenshot, even if it's fake, I won't lose my job, but still, what happens in the room stays in the room because there are few features which is, yeah. No, I'm just trying to type it. It's not, it's a second. One second. It's not in my laptop, it's in the other laptop. See, it's like the DevOps concept, it works fine in my laptop. Fine. Is it all well now? Right, so hopefully it goes faster. Okay, so I will introduce you. Generally, I like to have my slides with bit more lot of fun memes, but today I'm talking about my company, so I'm not allowed to do that officially. But still, I'll just put some few screenshots here to make you laugh. But probably I'm a bit older, so 17, 18 years back, there was no DevOps. There was a dedicated build engineer, admin who deploy. I don't know how many of you there studying or working at that time, I don't know. But there was a dedicated build engineer who will send us class file or some updated code. Overall, we will deploy it, stop the server, copy, paste it. So this would happen 60% of the time, deployments work every time. This is a common scenario. Then the DevOps happened and all these tools came in, right? In 2015-16, I was working with Oracle. At that time, I was working for a product called Enterprise Manager. It's more like an APM solution, application performance monitoring for Oracle applications. I was introduced to something called Docker or containers, which is probably the starting point for Kubernetes. So I learned it all, trying to find a job after that, but everywhere they were expecting at least 8+ years of Docker experience. Docker was even introduced in 2013 or 14. I was there in 2016, but I couldn't get that. They feel containers are new. I don't know what containers they're talking. Then the ML came into the picture 2020, 2021. People talk about hallucinations today. At that time, we call this a confusion matrix. I was a data scientist. How many worked in data science background here? Few. Okay. You know what is confusion matrix? I know. That is true positive, false positive, true negative, false negative. Okay. So this is a common issue with an ML modeling. Bias and all these things will happen. So because the ML was not adapted very frequently for exam business, right? There are a lot of things, but I found this is fine. Then after the advancements today, I'm just going to combine all the past 3 slides going forward. DevOps, containers, and then the AI. How the evolution is happening. And how GitLab is trying to address. Probably, I'm sorry, I need to walk. Every time here, it would like at least 20 seconds for that. So, how many of you heard about GitLab? I'm in a room with people. It's not GitHub, by the way. Yeah. Sure, right? Okay. So last month I was in an event, Gartner security event. Half the people came, hey, can you show me OTel? I said, please walk 5 foot down there, does it help me? They will show you the OTel. But hopefully, GitHub versus GitLab, you know what it is. Right? So GitLab, we have an offering called GitLab Duo, which is more like an AI offering. We don't have our own model. We believe on a multi-model approach. So we depend on Google and Gemini, Robotics, or Anthropic Cloud, or any model the customer wishes to use. But our philosophy, at least GitLab's philosophy, which I kind of agree, which is that we believe having AI not just on the code spectrum, there are multiple places where AI can be helpful. Right? The entire SDLC. Everybody knows SDLC. Super development. I see. Okay, you're a big right. So how we differentiate AI across, right? So in a realistic world, how many of your developers? So I'd like to be in practice of these. If you're tired raising your hands, so I it's fine. How many of your developers hopefully in a realistic world, right? How much time you would develop a write code? 25%. Rest of the things, update tickets, managing politics. Right? Most of the jobs involve the code on it, right? So having an AI generating code will not solve the entire problem. Right? So we figured out not just we, it's based on a survey and industry standard. Hardly a developer spends 25% of the time coding. Rest of the time they would work on documentation and works better documentation, faster onboarding. Whenever you join a new team, figuring out things faster. Important stuff is security. Because the industry is moving towards something called shift left. Right? There's a concept called shift left. What does ideally means is security today is more like an afterthought. You create an application, you deploy, then a security team comes in, test it, hey, I found one, goes back to the developer. It would take months to fix it, right? The shift left ideally means moving the security as close as possible to the developer. That is shift left. The challenge that we are seeing on most of the customers I interact with see is not every developer knows the nuances of security. Some 3 weeks back, there was a Kubernetes ingress right now. I know that, but I don't know what it is initially. So a lot of developers don't understand the security terminologies, right? So how can we address? We wanted to give all these ammunitions to the developers so they can make an educated decision. So the actual shift left means starting. You should start all these things much earlier in the life cycle. So everything would be faster. So whenever I'm talking to a customer, recently I've been with one of the biggest bank in India. I don't want to name it, but you'll figure it out, public sector bank. Their CTO, when I met their CTO, no CTO would simply wake up one morning and say, I want to consolidate all those. Nobody will say that. Okay? When we ask them, what is your problem? These simply 2 points that CTO told. I want a faster time to market. Whenever there's a new feature that my team is working on, I want that feature to be in production to the customer in a faster way. And I wanted to have an edge over my competition. These are the primary objectives of any executive. Developers, we won't have a different set, but executive things. Then you need to ask why, how to achieve all these things we do. So these are some of the places where we feel AI can help you to fast and 10-year process. I have a demo. If I figure out the way to do a demo with one hand, I'll try to do it. Or if not, during the week, I'll show you the demo. But I'll just try to show you at least some videos. So initially, GitLab came with this duo. It was not agentic. Agentic is a new evolution in GenAI. Right? It is like if it is a typical GenAI or a prompt, you'll ask the question, it gives you a response. Agentic goes one step further. You tell give instructions. Hey, you want to do this, it will do it prompts. Right? So we started with an LLM kind of a prompting, which I will show in some time, where you can ask the agent to generate the code. If there is a vulnerability, explain the vulnerability, or fix the vulnerability. So the developer can do it and once that is done, it will create a merge because a human in the loop being created, then the typical process. Or sometimes, I don't know how many of your operations like, have anybody debug Jenkins pipeline failure? GitHub actions by people in the last row. Generally, the operation takes the last row. That's so okay. But anybody in the front row, developers will just next. So some DevOps legs that. So when you debug all these things, finding a root cause, it takes a considerable. You need both tons of logs, tons of metrics. I've been working in Dharmesh for observability space, so it is great, right? So how we are able to do this? We have simple AI embedded in the ecosystem. Hopefully, I'll show you. Troubleshoot. It will do the root cause analysis for you. So these now we introduce something called an agentic AI orchestration system using Amazon View. Hopefully, the demo, if I have time, the easiest one to do. I'll show you how the Amazon View implementation also works. Okay. So having a product idea, building, securing, and delivering. This is what a simple SDN is like. So having AI into the end-to-end spectrum would definitely help you to read software faster. Okay. Computer feeling static. Okay. So all these things I'll skip. One interesting part I will do it. Most of the LLMs that you see, it is on, it needs a lot of heavy resources. If you need to train your own model, I don't know who does it. If you're doing deep sea, you might. But if you deploy your own model, again, you need a lot of GPUs. I don't know how many of you did deploy any LLM in your own laptop. So we have an option here called self-hosted model. So this is some we are having a customer of Indian government, ESPN, hopefully we publicize that. If you're filing your income tax is one of customer, they are using the self-hosted portal. Take another level, deploy it in your own data center, and all the SDLC will be enriched by AI. It works without any. This is one key differentiator, but a lot of upside customers, BFSI customers use this self-hosted deployment. Like the keeps it even, you don't even need HPU, right? All these things are fine. Oh, I'll move to demo. So I will like teach you too many theoretical stuff. In this particular case, what I wanted to highlight here is, as saying generally, even for a developer or any operations level, on a day-to-day basis, you would be using at least 7 to 8 different tools. In your SDLC, if you know how many tools you use, you develop code, you check in code somewhere, from here Jenkins or some CI/CD will kick in, from there secure it, or you push to Artifactory or package registry, then CD, Argo or you other tool you use, goes to Kubernetes or some kind of a deployment and runtime protection. Minimum 6 to 7. If you use observability on top of it, 2 to 3 more. Okay. What we are saying is the faster to market is impacted by these things. If there is a production issue, navigating across all the 5 or 8 different tools to figure out where exactly the issues takes a considerable amount of time. So what we are seeing today is everybody is trying to adopt a single platform as a service, where it can help you track starting from planning stage like GA till the deployment. So you can have an end-to-end visibility and faster time to market. Okay, and have a better control, IT governance. So this is what we are seeing a shift in the industry. I'm not saying GitHub is the best in the market. I'm saying most of the tools that customers looking out for is more like a platform. Like there are other platforms that are in the market. Harness is one which is very good. Don't know. I don't know how many of you know Harness. It is a decent product. And GitHub, they're also having an integration. They're also very good business. So more and more customers, enterprises are looking for consolidation. Okay. So ideally, this is something that's generated using chat. It's a free version which you see a lot of spending things. But what today people are expecting is they expect, if I say a single platform, most of the customer expects completely. The platform should do literally this partnership. But what we're offering is we are giving a platform that has the capability to do hundreds of things in a smaller way. So the cumulative effect, when you just like mutual fund, the cumulative returns once you see it deployed, it would be much more better than the typical tool change call that you. Okay, this is what we are trying to do. Okay. So far, so good. I mean, making sense. Right? Okay. And I'll move to a demo part if I'm able to do it. But am I hiding this screen or it's all good? Okay. So one thing I wanted to show is, okay, I'll stop the typical duo things here. Let me move on to an agentic side of things. So assume this is a new project I just created. It's a simple Kubernetes demo with a README, no data stream. It's a very plain vanilla project. Suppose in a typical one, you would have a project manager, who would be breaking down a requirement into multiple user stories. You would have a requirement, right? So what happens, you would fill the requirement in Jira ticket or somewhere else, and you would assign to multiple engineers to work on it, right? So why I said AI would be an next engineer is in this case, I have a requirement here. I want to create a new Python Flask API server. So I'm just copying this line. I'm just going through the demo as it is. I'm just going to create an issue. Issue is a Jira alternative, which is available in GitLab. It is what we call GitLab planning. Again, we are trying to consolidate everything. I'm just pasting the requirement here. And the detailed description is a project manager would tell me, create a Python Flask, create a stuff. Sorry for this. Let me try to increase the font. Okay. The structure, subdirectory, I want to create an application, I need to create Kubernetes, deployment, manifest, and all these things. So I'm just copying this description. These are the things I want to do. Okay, I'm coming back to the issue. I'm just pasting it here, creating an issue. So far, this is the typical process that you would do. So where the agentic comes into play is, okay, you assign it to a developer, or hopefully in future, you won't be anywhere. But in this case, I'm just doing cube. Interesting. Internet is not working. This is something that always happens to me whenever I'm doing a demo to a customer. Hopefully this will get resolved. So then I just all we need to do is this. Comment a single command stating that queue and develop. Oh, sorry, it's my mistake. Should be this queue. And I asked the queue, the agentic sign of OS, hey, can you take this description and create a project form? It looks into the entire context of your project. If you have other projects in the ecosystem, it scans the project and understands the project. So it creates a code which is very relevant to your existing. So it will take some time, but ideally what happens is, once I do this, it would create a merge request like this. Okay. So I just created one project today morning. So I created an issue, new class server. I just did the same thing here. All it does is it finished generating the code and created a merge request point. So as a developer, I don't need to start with everything from scratch. All it can do is it give me an entire code like this. This is the root, these are the Kubernetes configuration, this is the typical container structure. It gave me an extra at least. Still, it won't replace us, it is still not there yet. But as a human in the loop, it is your responsibility to figure out, for example, in this case, I wanted to copy all these things and make some changes. You can ask it to do the change. So in this case, if I wanted to, hey, can you change the structure of all these groups into a separate project? It will be able to split the created code and create it to whatever customizations you want. Then you can ask it to, hey, can you review the change, please? There is a transform, there is a review. You can ask it to review your entire code. So it will look into the code and give you the review performance, how the code is, etc. The interesting part, what I really like about this particular part is, this is a common thing. How many of you worked on a migration project? What migration? Java migration, Spring migration, Angular to Get. Right? PHP. Right, thank you. I have people of my English here. So yes, these migrations are very prevalent. Most of the customers like get tons of resources and huge amount of time to do these kind of migrations. With agentic, it is even more easier. So I just created a simple migration today morning. I asked, this is Java 7. I wanted to do Java 21. So I created a Java modernization, put some commit, and transform it to me. What it does is it read your entire code, uploaded the code, completely did the transformation, everything, that created a merge request form. In this case, it gives me a clear-cut idea because 7 might have few things, 21 might have integrated a lot of things. So it clearly tells me you wanted to do these steps to make sure your project is completed. You can ask it to do it as well, but you can direct the queue for an agent to handle these steps. Okay. Is it interesting? Okay. Last question. So agent, the way we are thinking is this, having an agent kind of a support given to you, all the developers, much earlier than I've seen. These are not security teams, these are not product managers' job. All the developers can make their educated decision based on the details that we provided to them. For some reason, one of your pipeline is failing. So I will show this one might be interesting for you. So I have a project, I have a ton of pipeline here. So the pipeline failed. And if you want to figure out what is the failure, right? Generally you will go through the logs entirely and figure out, right? We have an AI, as I said before, just ask it. It will go through the logs, your traces, metrics, everything. It will give you the root cause analysis. It will not be 100% perfect, but it would at least save you 20-30% of it. But these are not generic fixes because it understands your code, because it understands the context more like an app. We have our own vector database. It will be able to give you, hey, in your code, fix this. copy this, go back to your code, fix this. At least it should be able to resolve some of the issues that you're currently facing. We also, if you're interested, we go a little bit deeper as well. We also have something called a security dashboard. One of the key parts which I mentioned about is making the developers aware of all the security nuances, right, which is a critical step. So in this case, I'm creating multiple security scanners. So in this case, I have dependency scanning, SASD, all these things are on. So let me open this. Hopefully the AI is there, if not, okay. So this, if a developer comes in, if I ask the security team comes, creating an issue, the security team sees this one. Hey, I think this is a critical issue for me. I'm creating an issue. So ideally, an issue would get created with the entire context. It would be assigned to the person that you want to fix it. All these things are fine. But for a developer who don't have context of security, it would be challenging. You need to do the research, you need to do a lot of analysis before you do it. So how we are helping the developer ecosystem is this. So there is an option on top which says resolve with AI, explain with AI. So if I ask explain with AI, it again takes the complete, it understands your context of your code. It takes the complete vulnerability. It tells me this is what the vulnerability is. So vulnerabilities. This is how we fix it. Okay. And follow the best practices. So for a developer to have this explained in a layman term would be like a big evaluation. And it would help them to accelerate things. We are going one step ahead as well. In this case, if you can resolve it. If the vulnerability is fixed, and AI will not just generate a random code to you. It will generate a code based on your own context. So in this case, it will create a merge request and assign to a human who can review it and accept it if they feel this is a right fix. Right? So having okay, the MR is created. If you go through the changes, if there are changes to fix it. In this case, I don't think the changes are still generating. It's a simple fix. So, likewise, whenever an MR happens, just immediately a pipeline will get in the backend. What do I mean by a pipeline? It is your CI/CD pipeline. It is to make sure whether the code has been generated by an AI or a human. Whenever a merge request is raised, automatically just take the questions. The pipeline will get ready to make sure it is free from vulnerability. As well as any kind of issue that you currently face. I'm just stopping here. Any questions? You can still go, but don't want to worry about it. But any questions you have? Yes. Right. The question was which model we are using behind the scenes. So we do not have the own model. We believe on multi-model approach. So we have Vertex, Nalla, DeepSeek, Claude is another major player, right? So depends on the use case, we recommend ones. For example, code generation, based on our analysis, we saw Claude was much better. So for code generation, we recommend Claude. Or if there's a root cause analysis, Vertex was better. It depends on the use case. We recommend ones. And none of the models are whenever there's a new model in DeepSeek came in, we started consuming DeepSeek. The value addition is, even though you're using models and LLMs, none of your data would leave GitHub. None of the data would leave the premises. So the model, when we send a context, it would be filtered at the GitLab. We have something called AI gate. So that will filter all of your code. None of your code will leave the premises. Okay. The privacy first AI is something which we is very, very important. Some of the customers I can name it here. Famous SBA is one of our biggest customers. They are using almost like 2,000 users of SBA employees are using this AI model. Last week we closed even a bigger deal with them. Okay. That's the reason I was traveling. And Geo, Government of India. In Government of India, they have an income tax department. GSTN 2.0 is coming. GSTN 1.0 was there. GSTN 2.0 is coming. They are going to use this. Finance Ministry, you can go. Almost like 20 banks in India using. And out of 25 banks are using AI, not everybody still skeptic. It takes a lot of time. SBA, for example, we've been working there for 1 year to give them a little bit of confidence. AI would really to the next step. Right? So AI is a most abused word. I'm sorry to use that again in this meetup today, but if you use it in a right way, it can help not just developers, everybody in the entire ecosystem. We can increase it. Also keep yourself updated as well. Agentic is there, N8 and line chain. These are buzzwords, but I don't think this is going to go like blockchain. Blockchain was a buzzword a few years back, now it's like completely outdated. In terms of the wallets, the things that ledgers that we try with it. But AI is here to stay. So if you want to look for a career, at least without stability, I have a mortgage at least for next 5 years hours. So I need to keep myself updated. But if you are interested, please invest a little bit on yourself. Learn the agentic things. Okay. So eventually they might not need us, but if you know the nitty-gritty details, how to find your all these things, you are able to consider. Okay, I think that's all I have. There are a few videos. The demos are a little bit steeper as well. Sorry, I couldn't show it on hand. It's getting entertainment. So if again, important one, if you wanted to give it a try, it is free. Please sign up. You go to the GitLab site. We are offering 60 days trial. Free 4 credit cards. And create a cloud instance, you will get this one. Just take your hands. See if it's good. And we're not charging for queue. It is all part of the prices. That's it. So we are working on something called enhanced quality assurance. Whenever there is a AI generated code or human generated code review alone will not solve the problem. It would suggest, it would also enhance your existing code quality. Code quality is another part. I don't know how many of you know something called TD, technical debt. If not, at least try to pick up this terminology with something you would see going forward or not, because people are white coding. How many of you know white coding? White coding. Good. Okay. Bad. It's not bad, but people are randomly generating code. It would eventually lead to a lot of technical errors. So you would need these kind of mechanisms in place to prevent any kind of a code assurance system. Okay, this is, if you're looking for some of the leaders in the AI code, Gartner released a report this year. Of course, GitHub was the leader. So GitHub, but GitHub was also on there. Okay. Look for tools that you see here. AppLine is really good. I like something called Tablet. There is something called Windsurf. How many of you heard about Windsurf? It's a really good tool. You should try. Or Cursor, amazing. Brilliant. So in terms of tools, we have ton of tools. Find the one that suits your need. But ideally, as a developer, if most of you guys are starting your career, don't just look for the shiny new things. Always first the problems first, find the issue. Then you find the tools that solve the problem. Now what is happening is a lot of tutorials and saying in the market is they give you the tools, then you will find a problem to solve. You just approaching in the wrong way. Always attach it to some kind of a revenue generation. If you want to make yourself a replaceable, attach it to something which is like dollar value to the company. So you add value. This is my main plan. If you want to have a detailed demo of GitLab or any other, I used to be a blockchain developer for a brief period of time. So if you're interested, happy to discuss it. Any other questions, guys? We do have time. He's standing at me, but I hope it's done. I'll be here till the evening, not the evening, but at least the first half during lunch. There are any questions, please feel free to answer them. Okay, important slide. You will feel enjoyed. Thank you. Hope it was useful.
Awesome. Again, a huge round of applause for Arun. So I think you need quick break, guys. We are moving forward with like 15-minute break. So you can have tea, coffee, like just left side after the lobby. So you can have and come back within 15 minutes because we are already running behind the time. So we have many laws planned. So please come back within 15 minutes. Thank you. Next slide. So moving forward with our next talk, Kyverno Beyond Kubernetes by Sachin Agarwal and Anudeep Nalla. So over to you, Sachin.
Yeah, Meetup. Right. I'm doing amazing. And it's driven by it comes from that that is the thing is saying is I as far as the sorry, already makes a big part of the scene. It does not happen. Those hard was what they are. Yes, from all the universities. Yeah, we have pretty big. Behind so optimize that plus break the fall. Migration is totally out of possible. So that was trying to not raise for Hey guys, hello everyone. I hope the 15-minute break might have given you some energy to bear with me for another 20 minutes. So today we are going to talk about security and before security, I just want to understand like how many of you know Kyverno or have heard about Kyverno? And how many of you are belonging from a platform engineering team or platform? Okay, so a little bit brief about what Kyverno is and what we are going to cover for today's session. So I'm Sachin Agarwal, working as a senior solutions architect at Nirmata, and along with me I have my colleague Anudeep Nalla, who is working as a customer success engineer. Right, and today we are going to cover a couple of areas of Kyverno, why we need Kyverno, what is Kyverno, right? What are the capabilities of it, right? And how you can write a policy using Kyverno, right? And how, so typically whenever we talk about Kyverno, it is typically being attached or being used vice versa with Kubernetes, but what is beyond Kubernetes that Kyverno can bring, right? So that is the main concept of today's discussion, and we will focus on that, like how we can take Kyverno policies beyond Kubernetes and apply it to the areas where Kubernetes is not there, right? Right, and then we will also talk about the shift left approach, how we can achieve a shift left approach with Kyverno JSON policies, right? So to start with, I'll just introduce a bit about Nirmata. So Nirmata is a main creator of Kyverno. So we created Kyverno back in 2019, and then we have donated it to CNCF.
and currently it is in an incubation, which is again, like, it is going to get graduate soon. So that is the journey that we have, and as you can see, there are Fortune 500 companies who are using Kyverno in their production environment, right? And we have a very good response from the community. If you can see, we are more than 3.2 billion, but it is now ever growing, and it is close to 4 billion plus image pulls for Kyverno. We have a very good GitHub star ratings, right? And we have a very thriving community of developers who are actually working and contributing to Kyverno, right? So now what is Kyverno? So as I already mentioned, Kyverno is an incubation in CNCF as an incubation project, right? And the word Kyverno in Greek means how to govern your things, right? So basically Kyverno means govern, right? So typically the idea came from the concept where Kubernetes by default doesn't ship with all the securities, right? So if you just run a Kubernetes, vanilla Kubernetes on your infra, it doesn't provide security by default. You have to have certain components which will enforce or which will make sure that there is a security in place for running Kubernetes environments, right? And that's why we created this Kyverno. And it works on an ideology of admission control, where any request that you are sending to Kubernetes can be validated against certain policies, right? So earlier, when we started, Kyverno was much more cloud native. It was much more tied with Kubernetes and was actually being used quite heavily with Kubernetes manifests and Kubernetes workloads, right? So you already know if so whoever has used Kyverno, they already know that there is different type of policies that you can write using Kyverno, which is validate, mutate, generate, clean up, and image verification policies, right? But the idea is now we have to take it forward. We have to make sure that it goes beyond Kubernetes and it can support all other constructs that can be validated using Kyverno policies. So that's why with the new versions of Kyverno, we are introducing another layer called CEL, Common Expression Language, which can be used to validate any JSON data that is there, right? So you take any JSON payload or any configuration that can be defined in a JSON format. Typically, you can validate it using Kyverno policy, right? So that is what we are going to learn about today. So there is another concept of validating admission policies that is getting introduced in the newer versions of Kyverno. So you will get to know more about it in the recent releases, right? So now let's first understand what are the capabilities that it brings to the table and how you can use and leverage Kyverno in your environments, right? So first thing, when we talk about policy in general inside Kubernetes, there are two major products that came into mind quickly, right? One is OPA, Gatekeeper, and another one is Kyverno, right? And definitely most of people have worked with OPA also, and a couple of people have worked with Kyverno also. One of the things that we have inference from all the community events and even interacting with community is that the ease of use with Kyverno is much more better than OPA, because it's all YAML construct that you have to deal with in Kyverno. Whereas with OPA, you have to write, you have to first understand and learn the regular language in order to write those policies in OPA, right? So definitely ease of use is one of the biggest factor, because of which it is widely being adopted in the community and is being used in a lot of organizations, right? Second thing, Kyverno not only work as an admission control, it has a CLI also, which can actually help you in building the whole robust solution and the workflows for testing out your policies before it is getting deployed, right? So even you can write Kyverno CLI jobs to actually validate your Kyverno policies that you are constructing, so that you can run it against certain unit tests, right? And those unit tests will nothing be but a manifest that can be deployed in Kubernetes, right? So you can validate all those manifests against these policies using Kyverno CLI, right? And when we talk about the auditing and reporting, there are actually ways in which so Kyverno came up with a reporting group, right? So it's a standard reporting capabilities now which is being adopted by a lot of other open source projects also. So reporting can be integrated with any solution, open source solution, and it has a standard construct now available open source, so that if any tool can use those standard reporting mechanisms to generate the reports, audit reports around any violation that is happening in their environment, right? And as I already mentioned that it supports multiple type of policies, which is validate, which can validate a particular condition for a given resource, mutate, which can actually change a configuration which is intended to be based on the admission. So anytime you are admitting any resource, you can mutate your resource according to the standard configuration that you want, right? You can also generate a resource using the event. So let's say I'll give you an example. Let's say you create a namespace in a Kubernetes environment, right? And you want that at the moment Kubernetes namespace is being created, you create certain network policies around it, right? So those network policies should automatically be generated whenever a new namespace is creating, right? Or you want some advanced use cases, like you want some action to be done based on certain event inside a Kubernetes, right? So all those things can be done using generate policies. And definitely, image verification is one of the biggest and most important factor of supply chain security. If you are actually looking forward in applying those supply chain security in your organizations and want to verify whether the images or the artifacts that are coming from a central repository or central artifacts are genuine or not, right? So how you verify those artifacts and the integrity of those artifacts that are coming inside Kubernetes, right? So definitely these are different type of policies that you can write, and we have a very good library of 500 plus policies that are already available in open source. You can use that, and you can even build your own policies, customize your own policies according to your need, right? And the next thing that is coming is beyond Kubernetes, how we are taking this beyond Kubernetes. So let's first understand from a novice perspective, or someone who doesn't know about Kyverno, how he can, or how he or she can actually author a new policy, right? So typically when we talk about Kyverno policy, the construct looks like something like this, right? Where we have a policy in which you can have multiple rules inside it. But so again, it's a classic chicken and egg problem, that do you want multiple rules inside a policy, or you want single rule in a single policy, right? So there is different. See, where what it is doing is, I'll just go one by one so that audit, right? So what does an enforce and audit do, right? So enforce is typically enforcing a policy that if a particular resource is not passing that policy, it will be blocked from the deployment itself, right? So at the time of admission, a typical admission flow looks like you authenticate, you get an authorization, and then you deploy it in a Kubernetes cluster, right? And that's where it goes through the admission review, and then it gets like the data is getting stored in the HCD, right? So before data getting stored in the HCD, it is actually being validated against this policy. And then the validation failure action defines whether you want to create an audit report around it, or you want to enforce and block it at that moment itself, right? So a typical validation failure action with enforce mode can block your deployments or any resource that is getting admitted to Kubernetes, whereas audit will do a policy report against it, right? So it will not block your resource, but it will generate a report against it, and then you can actually see what is actually getting violated because of this policy, and you can fix it, right? And then here is a rule which actually matching for a resource of kind pod, and then it is validating whether the particular label, team label, is present in a deployment or not, or in a pod or not, right? And similarly, this is a very basic example, but you can even go for a very advanced use cases using this policy, right? So now, what's next, right? So we all know that Kubernetes is Kyverno is simple, right? And there's no coding requirement needed in this particular tool. You don't need to learn any new language to actually work with it. But what's next, right? Because things are going beyond Kubernetes, and we want to capture an area where you can validate certain aspects of non-Kubernetes resources also, right? So that's where the portability comes into play, right? So it is not portable enough during the time when it was cloud native, because it can only work on Kubernetes resources and manifest. But now we want to increase that portability factor to it, right? And that's where the new project called Kyverno JSON got introduced, right? Which actually allows Kyverno to go beyond Kubernetes and help developers or platform engineers to validate certain JSON payloads also, or even YAML constructs also, right? So what actually got changed with this? Now, typically, when before the new releases that are going to happen, the typical Kyverno policy can be written in such a way where you can have a cluster policy, you can define the resource kinds, and then you can also define certain match conditions and the validation conditions, right? But now what is changing with the new version? We are introducing another CRD, custom resource, called validating activation policies or validating policies. And now we are going to use a CEL language, and how it looks like. So this is the classic example. So earlier, you can define a condition using the what you see in the left side, where you have replicas greater than 2, right? But with the new policy set, what you can have is a CEL expressions, right? And CEL expression is something which is being adopted across different open source tools, and is being now the go-to expression language for validating any new configuration that is going, right? So that is where we are actually heading, and it's working fine. It's on. I think yeah. Yeah. So so now this is the new way of defining a Kyverno policy, where you are using the CEL language, and now what change does it bring, right? Why we introduce the CEL language? You will see it in our next examples, right? This is again one example where you can use different pattern using CEL. Even you can loop through the data very easily, which was quite difficult in the conventional way of writing the Kyverno policies, right? So this is one example, right? So if you see here, what we are doing is we are writing a validating policy to check whether a given ECS task. Now this is beyond Kubernetes. It is not a Kubernetes workload. ECS task is another AWS service which is used for running containers, right? So typically what we are doing here is we are checking for a given resource in an ECS task whether the network mode is given as AWS VPC or not, right? And this is how we are writing that particular policy, right? Where we are using the asserts to check whether AWS ECS task definition inside that if network mode is AWS VPC or not, right? And this is how typically you can apply these kind of policies to any Terraform code or any JSON payload that is getting embedded to a particular infra, be it cloud, be it any infrastructure tool that you are using. Is it Terraform? Is it CloudFormation templates, Polemy, right? So every IAC tool or any data which is being mentioned in a form of JSON or YAML, typically you can write the policies against it and you can validate it, right? So to see all this thing in action, I would like Anudeep to come and show you some demo part of it, like how it works and what is the look and feel of it. So over to
Thank you, Sachin. Hey folks, this is Sandeep. Before going to the demo, I just want to add one point, which is related to cleanup policies. So, what cleanup policy does is, suppose let's say, like you are keep on changing the image requirements, images in the requirement, and that creates a lot of critical errors. So the each stage is okay. After a few days, there will be hundreds of it. And with the help of cleanup policies, you can add a condition where, before 10 days, whatever the critical errors will be there, it will be cleaned off. This is an example, like, suppose if you're not deploying any of the deployments using headshots, you're deploying manually. And people tend to forget the addition of services. Like people delete the deployments, but not the services. And services will be a lot of like, and we have to delete manually. But we can create a policy where it checks each and every service. And whatever the service it doesn't have any endpoints, right? It is similarly, you can make a condition like what are the services created before 7 days or anything. So that is one thing I just want to add. So when you come into the demo, first thing is like why we need to set up Terraform. Because nowadays generally we deploy like Terraform code using pipelines. Okay. And most of these configurations happens because of the cluster is exposed as a private endpoint or some misconfigurations that creates a lot of attacks. So if we add, like we have a couple of tools called Kyverno JSON or the HTTP CLI, you do download and you can do it and you leave the terminal or you can do it in the pipeline as well. So with the help of it, we'll be validating the JSON payloads. I'll be showing like how the payload looks like and all the points already Sachin has covered it. So it scans the JSON payload. Yeah, here I've created a detailed repo where it contains configuration files of uh, Terraform code. Here I'll be scanning the ECS, ES, and the Lambda Terraform code with the respective policies. And you can create multiple policies on your own as well. So it's just a simple YAML. So here the config files, Terraform have the Terraform code related to ECS, EKS, and Lambda as nature. Here in the controls, I have ECS, EKS, and Lambda like policies. This is not the like Terraform payload the JSON looks like. So then how will we be creating this payload to JSON? We'll be using the Terraform plan and we'll be outputting as a binary. And with the help of binary, we are passing it to one file which is payload.json. That's how like we are going to create the JSON file. And let me explain like one of the policies where it stands for whether any of your EKS cluster is having public IP or not. So we go to the payload.json. The policy contains rules, matched and assert. In the match section, we are matching the AWS ECS service in your payload.json. So if you come here, so like this is the plan list and like completely tree plan values root module, and we are matching for ECS service. And in the assert, we are checking for does the assigned public IP is true or false.
Here you can see that this is what they are matching. So let me go to the pipeline. In the pipeline, like I'm using HCL. Like you can choose the binary, or like we have an action in the marketplace as well. I'm using the GitHub action installer, and I'm using Terraform script. So actually, as I showed before, like it runs the Terraform plan output, and it stores as a payload.json in the config files. Let me show this pipeline. Yeah, it's can like easiest Terraform code, and it gives like pass off queries in the pipeline. But let me change this assign public ID in my Terraform code to true. So this creates a new payload.json, and the policies will be scanning the new payload.json. So we get Kubernetes. Now you can see like the Java has failed. Why? Because like we have added like the public IDs for true. So here you can see that for the public IP it is provided and it's scale. Similarly, like we can do for EKS as well. Like I think there's a job running districts for EKS. Yeah, here like this code has been failed because my EKS cluster has public endpoint. I have added the Terraform code like public endpoint is true, the site is failing. I'll be sharing this repo with Kunal so that like you can check like how the policies and how the Terraform file works. Similarly, we have a scan for Lambda as well. We have added like right now I have added like couple of policies like the eagle code, but like we have a repo available as well where you can find multiple policies. And one idea. Here, like in the same pipeline, I have added both, like which is passing payload JSON and the failing payload JSON. For the passing, you see like all are passed, and for the payload.json, like you can see all the checks here. While it is failing, here you can see like while it is failing. And that's all. Any questions, Shanu? Policy, yeah. We have set up policy. Mm-hmm. I have validated level. Yeah, by default, suppose let's say there are a validate, mutate, generate, and cleanup, right? By default, the priority goes to mutate, generate first, then comes the validate. That's like on starter. Like suppose let's say you have 500 policies, like what policy will be applied faster? Because anyways, like that doesn't need it because these policies are be applied in a very faster way itself. Okay, so suppose I have 10 lists. Okay. The one on the one complex policy or So you can integrate with we have a open source policy reporter. You can see all the more details over there, and you can also integrate with Grafana. You can deploy Prometheus and you can share all the details to Grafana. We have a Grafana dashboard and like in which namespace how many lists are getting involved in there. You want to integrate with that particular solution is you have to deploy policy reporter individually for each cluster, right? You can't consolidate all the cluster into one UI and see everything. Because policy reporter it works with the particular aspects of Kyverno that is running a particular cluster. So we can't consolidate, let's say 10 clusters are running with Kyverno and you want to consolidate everything into one Kyverno cluster, that is not there in open source, but with enterprise ecosystem. That is something which is a effective by enterprise and open source. Also, just to mention, it not only stops on the Terraform level that you can scan Terraform codes for any misconfigurations. You can even run these policies for Kubernetes manifest at the pipeline level. You can even run policies for Docker files. So typically, Docker file is something which is a very important manifest in terms of creating and generating those images that can get deployed in Kubernetes, right? So how many of you actually think about the best practices of writing a Docker file? Or how many of you actually know what are best practices are there to write a Docker file, right? So that's where a lot of organizations they struggle and they find it very difficult to educate people and to educate developers to write a Docker file which is industry standard and it is lightweight, plus it is using the proper base images which are approved by the organization, right? So definitely, this is something which will really help any organization who wants to monitor or who wants to audit their Docker files and see whether they are following the best practices in terms of writing a Docker file or not, right? Because there are very much different configurations that you can define in a Docker file. For example, whether your image or your container that is created from an image should run as a non-root user or root user, right? So all those can be defined in a Docker file and you can enforce those kind of policies which can define that no Docker file can have a root user defined in it, right? Because it is typically a security threat because anyone can go and use the privilege escalation to violate certain things in a mode, right? So this is one example. Again, it doesn't stop on the Docker file also. You can even run scan against your Ansible codes. You can run scan against your like CloudFormation templates, right? You can run it against the full configurations. So any JSON data or any YAML data that is there as part of the configuration management, you can run policies against it, right? So that is the idea, and that is where the things are moving towards beyond Kubernetes in Kyverno, and you will see a lot of new developments that are going inside Kyverno in the recent release. Right. So that's all from our side. Thank you so much to all.
Thank you, Sachin and Anudeep. So I have a round of applause for Sachin and Anudeep. So moving forward with the next talk, and just last talk before lunch. So faster engine evaluating Presto and Presto C++ on TPC-DS by Shakyan Kushwaha. So over to you.
I can see a lot of guys are sleeping. Right. So I promise this will be the last talk before lunch. So I think just need your full attention here. after the session, if you do have any questions related to Presto or anything, right, can chase Shakyan for that, right? And I promise after that we'll go for the lunch. Okay. So please. So, hello everyone. My name is Shakyan, and I will talk about Presto. And as like, who are you all are sitting for a long time, so I try to keep it short, and it will be like a brief introduction, and we'll just focus on three things. So it will be Presto, Presto C++, and then TPC-DS benchmarks. So we are the and hopefully I will not take too much of your time. So let's get started. So this is a bit about me. So I work as a software developer at IBM, and I work on OS's Presto team, specifically on Presto C++. So, so let's start with what is Presto. So Presto is an open source distributed simple query engine, and it is written on Java. And it allows us to run SQL queries across different data sources. So those data sources may or may not be based on SQL. They can be NoSQL databases as well. And it has a two-tier architecture. So we have a coordinator and a worker. So let's have a architectural overview. So as I said, we have a coordinator and a worker. So the coordinator basically takes in the query from the user. It passes the SQL, then it generates the query execution plan or fragment plan. And then it passes on all of this to the worker, and then the worker actually performs the query for you and then returns the results. So if you look closely, this is the coordinator. We can have multiple coordinators and multiple workers. For simplicity, we have one coordinator here. We have a high underscore to store the query metadata, like for any query, what was the ID, for how much time it ran, what was the result, and how much resources it took, etc. And then we have, I think it's not very clear. So, okay, so this is the coordinator. It has some components. It passes the query, has some optimizers, some scheduling also, like which query will be like which part of the query will be sent to which worker and all. So that is handled by the coordinator. Then we have, like here you can see there are four workers. This is our data source. So for example, it is here an S3 bucket. It can be like GCP or Amazon storage or like IBM Cloud, etc. Any kind of storage can be there. And we support like ORC or Parquet or any other kind of open file format. And then these are the workers. So the coordinator to worker communication, it happens through REST API. So we have the endpoints, and every certain time the requests are sent from coordinator, and then it gets the status of each of the workers. And then that can be viewed from the like Presto UI or CLI as well. And then worker to worker communication have a serialized page format. So it's like a page format, like a different kind of data transfer formats are present. So it is also kind of that format. And then between the worker and the data file, like we have a connector, like here it is high connector. So what is this? So for high catalog, we will use high catalog. We can have different kind of catalogs. We can have iceberg as well. And what it will do is, so it will act as a bridge between our file format and the schema. So coming to the limitations. So it is, so the intention here is not to say that Presto Java is slow, but we can do better. That is the intention. Still, Presto Java is being used in across many big companies like Meta and Uber, etc. And even Presto was developed by Meta. So
And then since then, IBM and other companies have been put together to develop it. So already many use cases are there, and it is already performing well. But still, there are some limitations which we should focus on. The first limitation is that, as you know, that like any code that you write on Java, it runs on Java children. So all the like memory management and all, the final control of that rests with the Java virtual machine. So we don't have that much control over memory management. Then we also don't have like there are various kinds of severe classification techniques like modernized, vectorized application, etc. like SMD. So these things are also not supported in Java. And then during like garbage collection, etc., there are like pauses which degrade the performance. So like these are some of the limitations, and we intend to solve this with the Presto C++. So what is Presto C++? So it is a full rewrite of Presto method. So that means that as I talked earlier, we are not making any change to the coordinator. The coordinator still is based on Java, but we replace the worker from that being written in Java to that being written in C++. So, and when we look at it closely, we see that it is basically a wrapper on top of Velox, and we will come to that in a bit. So it is a topic replacement for Presto Java worker, and it leverages Velox. So Velox also we'll talk about Velox later. So this is the architecture for Presto C++. And as you can see that here, the only difference that we have here is instead of Java worker, we have Presto C++ worker. And everything has remains the same. So it is built over Velox library. It supports vectorized execution. So like it needs like SIMD, etc. And then we can also apply a lot of runtime optimizations. So the executor is actually aware of the state of the system, and depending upon that, it can. So there is no fixed law of execution. So we can actually have like various paths that the system can take depending on the state, just to speed up the execution and save some time. And we see more like some of the optimizations when we move forward, and then you can like understand like what that means. And then it is like it also supports like prefetching, caching, etc. And then it also has some memory like advanced memory management features like memory arbitration, etc. So we'll look at these things in detail. Let's focus a little bit about Velox. So Velox was also, as I said, developed by Meta. So it is a library of reusable and high-performance components. It can be used for data processing. So these components can be used to build various types of execution engines. So as my colleagues also talked session about Gluten project. So even Gluten is based out of Velox, and Presto C++ is also built on Velox. So what happened, like what led to the development of Velox is that people in Meta, they had like different kind of workloads, and for each of the workload, they had a different kind of execution engines. And then they had different interfaces, different kind of problems coming in. There was no consistency on them. So they were like hard to maintain and optimize. And the user also did not get like a consistent experience. So they thought of coming up with one unified kind of engine, like a library which can be used to build different kinds of engines. What I mean by that, I think next slide, this slide shows it pretty well. So we have two different execution engines, and we are just replacing the engine layer with Velox. Everything else we are keeping as same. So this is like the superpower of Velox, you can say, that it can be used across different places. So it is an open, like it is a unified execution engine. It helps to consolidate data management systems. Like for example here, Spark. So like Spark and Presto are two different engines, but the execution engine can be like that layer can be replaced with Velox. So, and it also supports them the limitations that we talked about earlier, related with like vectorized execution or runtime optimizations or like memory arbitration. All these things are supported by Velox. So any engine that is inheriting it, that is based out of that, will support all those things. So one by one, we will just discuss like major of these like optimizations, etc. So first one is vectorized CPU execution. So what we do here is like in one instruction cycle, we try to process multiple, like in one cycle, we go over multiple sets of data. So it takes less time. So like a single instruction operates on multiple data points simultaneously. And one of the example is the, so it stands for single instruction multiple data. So instead of processing one data element at one time, assembly instructions process multiple data elements in parallel. This leads to faster execution and we reduce the number of instructions. So this leads to like very efficient use of our compute resources, and it is ideal for tasks like AI and big data analytics or graphics. Then we'll look at some runtime optimizations. So basically, as I said, that the program is aware of the state, and depending on that, so there is no fixed flow of execution. It adapts based on the state, like so based on real-time performance data. So instead of using a fixed strategy, it monitors the system and optimizes. Like reordering of conjuncts. So if we look at this query, there are two comparisons, two filters that needs to be performed on user table. And it's kind of like a very basic query. So I think most of you will easily understand that. So suppose there are 100 people, half of them are above 18, but only like 10% of them are active. Ideally, what this means is first we evaluate this condition, then leftover we evaluate this condition, and then finally we show the result. So suppose half of the people, so in the first iteration, it will go through all the elements of the table. So it will go through 100, and because half of them are above 18, then again it will go through 50 and then sort. So we'll need like 150 reads. Suppose only we evaluate this one first. So the first execution will go through all the 100 entries, but then the next one will only take like 10. And from those, we can say who are above 18 or not. So if most people are not active, then we can evaluate this one first and then go to that one. So this will, like here it is a small example, but our tables can go into very large sizes. And there these kind of optimization, we can have even more complex queries. So these kind of optimizations really show the impact there. So this way we reduce the reads and the execution is faster. And similarly, if suppose the system is aware that we have null paths, so the null checks, etc., also can be avoided. So that is also one of the optimization. Then suppose we are doing aggregations. So here also like suppose we are grouping by department. Okay, by department. So what we can do is like if the department IDs, like what is the cardinality of the grouping key. So if that is a very small number, we can use array for storing the grouping keys. If it is like a basic, like not a very large number, but still not very small, like in few hundreds or a few thousands, I would say, then we can use normalized hash function or if it is running into millions, like for example, customer IDs of some entity such as Amazon, so it has like millions of customers. So there, if we want to have like a grouping for all the orders that are done by one particular customer. And in those places, using a hash function directly for storing the grouping keys makes more sense, because there the hash function computation will not be as important as the fetching types that we need. So the searches will be very like very less costly, and so that will supersede our use. So depending upon like the use cases, we can do that, and that is what like I'm giving in the example also. Like for example, like there's a company, so like we can suppose that it may have like few like tens or hundreds of departments only. So there we can use an array to store the grouping keys. Then looking down, then we can have like customer ID here. So in these, okay, so this is the text. Yeah, here it can have like a large number. So we can use either normalized hash function or like standard hash function. So these kind of optimizations are there. Then as I talked about reordering of the conjuncts, here also during the while performing the joins also, we can reorder and check which condition has like less number of rows or column entries, like or entries that satisfy, and we can perform the filtering before join the tables. Suppose we join two tables and then perform the filter. Instead, we can first filter out and perform the joins. So these kind of optimizations are present. And let's look at some memory arbitration techniques also. So I think I am going very fast with these things, but like these are just basic overviews, like what all things actually led to us like pushing towards C++ when Presto Java was already a good and stable product. And so these are the real like improvements that we hope to achieve with Presto C++. So what memory arbitration means that basically suppose we have a query, it has it reaches the limit, memory limit that it is supposed to have. So it can actually borrow memory from some other query that is running, and suppose it is not using the full resources that is allotted to that. So what it leads to is that with limited memory also you are able to like use and like the query execution is equal to finish. So this leads to like a better use of the overall resources that we have. And similarly, even within a query, when we split the query into different parts, suppose some like operator is releasing the memory, simultaneously the next part of the query can reclaim that and use it. So it is done using the scaling infrastructure. So if you are really interested in going deep into this, I think we have like very nice documentation on DevOps, so you can check those out. So yeah, we like so as I talked about that memory can be shared on the concurrent queries to improve the memory usage. So all these things like bring a lot of performance boost. So as I said that we can do the query processing with a smaller like subdue, because we will be using like making use of the resources in a better manner. So and then we also avoid the performance cliffs. So as I said that because this like garbage collection causes it all won't be happening because we'll be running it native. So and then we'll be able to use all these memory management and vectorized CPU execution techniques. So these things improve the performance. And then also like it is easier to build in operator at scale. So because Velox is reusable, so it can be used like those primitives can be used across various data engines. Like for example, in Spark, like like my colleagues, as they talked about. So I work on Presto and they work on Meetup, like Deepashree. So like they both of us use the same dialogues. So the same thing can be used in two different engines. And then because we have more control over our system and it is running on a lower level compared to if it is runs on JVM. So we can actually understand the performance better because many of the things are kept hidden when we don't have much control. So that is also the case here. So Presto, the future of Presto is Presto C++. I just want to like reiterate that it is like we are not changing the coordinator and all. We are just rewriting the Presto worker in C++ on top of DevOps. And on average, we see 3 to 4 times of performance and scalability boost. We'll look at some of the benchmarks. I think we are short of time. Otherwise, I would have done some demos also. I would have generated some small data set and I would have ran the this TPC-DS benchmarks on Java cluster and C++. And then we also like we could have made it plotted and seen the boost and all. And by comparing the actual execution times. So it's like an ongoing community effort. As I said, that Meta, Uber, IBM, ByteDance, Euroclear, many other companies are working on this to make it happen. And our goal is to make Presto the best open source data lakehouse in the market. So we'll now see at like some of the TPC-DS benchmarks. So it's like that's the basic architecture. Like what we ran in the results are present. It's not actually the same, but it's something like this. So we have pbench, which is like a benchmark tool. We'll talk about that in the next slide. And then we have the basic architecture. We have some data file format. And it can be like here we are specifically talking about TPC-DS catalog. And then we have like worker and coordinate. So this is our question. And so yeah, let's talk about pbench a little bit. So you will find pbench, I think, on Presto only. So yeah, it is as you if you go to this repository, you will find. So it is like open source benchmarking tool for Presto only. And we can run various kinds of standard dataset benchmarks like TPCS, TPC-DS, etc. And you can also create your own benchmarks using flexible JSON configuration. And it supports multiple stages, random query order, bold and long runs. And it has other like utility commands for comparing results like generating data. It is written in Go. So if you are really interested in like running some of these like clusters on your own, then I would recommend you to go to this like this link, and then you will be able to like we have a very good and detailed documentation of how you can spin up your own like Presto cluster based out of Java and C++ both, and then you can run and then you can also run pbench benchmarks and compare for yourself about the queries. So yeah, so this is the result for the TPC-DS 1K. So 1K basically shows the size of the data set. So it is 1 TB. So what TPC-DS is like there are 99 queries, standard queries, and it is run. And then how much it takes in so as you can see that the native engine is way faster for 1K. And then this is the duration ratio. So these lines predict like how much time, how much more time the Java takes, like the divided the time taken by the Java engine and the C++. So you can see like the speed boost. It is 2 to 4 times. In some cases, even 10 times also. And then, so yeah, I did not mention the times it took to, so you can see the cumulative time for execution. So for 1K, the C++ worker, we ran this on 8 workers with a cumulative vCPU of like with 128. Those are the cores, and this is the total RAM, and this was the instance. So we had 8 workers for both the clusters, C++ and Java, and like Java took around 3 times the time overall. Then here also like C++ was like kind of twice as faster, I would say, if you look at the times. So the only change here is the change in the obviously change in the number of workers also, because we are running 10 times the larger data set. So it is 10K, which means the size of the data set is 10 TB. And this is the Presto version. So here also you can see that the native worker was way faster. And this is the duration ratio. And then this is for the 100 TB data set size. So we are only plotting for the Presto C++, and it took around 4 hours to complete. You can look at detail about it on this endpoint. So IBM actually released the announcement blog on this because like this was earlier not supported, the TPC-DS benchmark. So our effort was to like, if our engine is faster than the Presto Java, then we should actually be able to prove it with some standardized benchmarking. So that is why like the developers worked on this and brought the support for it. And then we ran, and then a very detailed blog is posted there. So still the Presto C++ is a work in progress. So because it is based on Velox, so now our like major challenge here is now how to make the UI as consistent with Presto Java or C++. Like for example, Java supports Iceberg. Presto C++ has read support for Iceberg. They're working on the right support. Then a lot of types, like some of the types, like most of the types are supported here also, that are supported in Java, but some of them are missing. So we are working on providing support for that. Then SPI is basically providing like the user with the chance to add user-defined functions, etc., to enhance the usability and to like instead of writing the code, you can like add your own things. So those things are what we plan to do and achieve in the coming future. And then to make it more stable, because like to make a stable product, it takes time, especially when we are consistently like adding new and new features. So we have to make sure that while we get more like functionality, that's the product still stays stable. And I'm seeing that people are very hungry, so just end it very fast. So this is like Presto open source community. It is very vibrant. Ahana is like a startup which was acquired very recently, last year by IBM. And like my team was 100 team only. So, and then you can see all the other big companies that are working together to build Presto. And you can actually follow us on our LinkedIn, or you can join our Slack channel if you are really interested in contributing. Please visit our GitHub, and suppose you want to join such like 80 sessions or sessions like these. You can also join the Meetup group. So we'll keep coming up with new virtual meetups or in-person meetups, and you can sign up for those from there. And suppose you are really interested in like knowing what all is actually happening inside of Presto on like a weekly basis, like what all the things the better folks or IBM people or just the open source community is working on, and what are the features we want to like talk about and push in the coming time. You can actually join our work group. So this is the link for that. And yeah, you can also like drop your ideas, like what all things you want uh, to be present in Presto. And yeah, it's a very interactive community and we will really listen to you. Yeah, so this is like some of the upcoming, like this one is the today one. And yeah, this is the Presto One Day, which is coming. It is a virtual conference. So you can, if you're interested, you can go to this website and I register for it. And I think that is the end of my presentation. So if you have any questions, you can ask or you can just go for lunch. Yeah, thank you.
Again, use round of applause for Shakyan. So, before moving forward with for lunch, I just want to have to tell this. I know you're slow on me. But actually the lunch is on way, so we're still like making arrangement over there. So just I need so in these 10 minutes we can have random quiz, like as we already planned the formatted quiz at the end of this paper, and we have prizes and all. So for this like random quiz, I'll just ask the questions. No, nothing will be played on the screen. Just you have to raise your hand and answer. We have some stacks to we will give away. So here's the first question. It's all related to the Kubernetes, so you don't need to worry that. Yeah. So which Kubernetes object is used to ensure a specific number of pod replicas are running at any given time? So maximum search. No. What is the name of the Kubernetes API, a resource used to define custom resources? Yeah. Yeah. Which Kubernetes object is used to inject configuration data into pods as an environment variable or files? No repeated hand size. Correct. What is the default service type on the Kubernetes? But when you create a service resource without specifying the type, that's the right type. I have to change the question again because everybody answered. So just raise the hand so we can reach out to you. Which Kubernetes resources is used to automatically scale the number of pods based on the CPU utilization or other selected metrics? One. Just raise the hand so we can select random people. Which Kubernetes component is responsible for scheduling pods onto the nodes? It's a brief. No. No. That's a service. Yeah. What is the name of the Kubernetes resources? Resource used to provide persistent storage to the pods. What is the name of the Kubernetes resource used to provide persistent storage to pods? And yeah. Not audible here.
Sound fast?
Persistent one.
Yeah. So guys, just hold for 2 to 3 minutes. I will let you go to the website for the lunch. So guys, one reminder, just don't utilize the other side of the premises, like the office side. So like they are not allowed that side. So you can utilize the cafeteria and other lobbies. And yeah, you can go ahead for the lunch, but please make sure you meet line and we can take one by one. So we don't make chaos there. Guys, we have snacks for you for the we will distribute at the end. So please be stay and we expect you to come back.
Answer to most of the is doing something. See it themselves. So we have this kind of experiences like that. One day, just in the past, the same stuff. So we see seals and when we were studying the things and studies and something that will make people find to be not enjoyable with that. So we didn't know so people like service.
So put on YouTube, that's why you can use that. So it's the share screen and there might be the
I disconnected the things. It's a free service that you're Right, hi everyone. This is my first time creates usually India Meetup, so super excited for that. But I'm going to be talking about how we can enhance observability and monitoring of high throughput transactional systems, right? So if I were to probably just ask someone, what do you probably make out of this particular word, high throughput transactional systems? Just as an open-ended question to anyone, what do you infer from this particular term? Perhaps some of you must be working professionals and working with big companies like Flipkart or Amazon, or if you talk about some travel booking sites like Expedia, Make My Trip. So you might have probably come across this particular term that you are dealing with a lot of high throughput. So can anyone probably give an idea what you infer from this term?
First, a lot of data being floating around in the system. This is very critical in the sequence of things.
Sivasankar.
I can go to translation. Especially step aside for time.
Absolutely. So we talk about something like a travel booking website where there are millions of people trying to make or do bookings of airlines or hotels at the same time. So you need to have a system that can very easily and can also keep record of all of these different transactions at scale. Or this could also be applied to come for fintech domain because there are millions of transactions happening, for example, on UPI. Right, at any given time during the day, there will probably be millions of Indians who are making a UPI request, and not just of course now in India, but also all the other countries where UPI is currently supported. So what we really need is to have a really robust way of being able to be able to ensure that these particular critical services are always up to date and there is no lag or latency getting involved. Because just imagine that you're taking part in a Amazon Big Billion Day or a Flipkart Big Billion Day festival and you're going ahead and ordering some item. Or for example, like let's say Xiaomi, they used to have these big flash sales where they used to sell thousands of their mobile phones and all of them used to get sold out in a matter of 2 seconds. Now, if these systems were very slow to react, and you would probably then lead to have things like database failures, or perhaps if you're having deadlocks, these type of problems will be very common. So in order to ensure that we are always having good uptime and we're not having any critical failures, system failures, we need to have a very robust pipeline for monitoring all of these different solutions. Because in distributed computing, where you have multiple nodes, multiple database cluster nodes, or you're using some kind of streaming service like Kafka, and you are having multiple worker nodes, you need to ensure that all of these particular nodes have good uptime and you can reliably maintain all of these softwares. So that's what my session is going to be all about today, that how do you actually optimize your data collection and monitoring of your applications at scale with the help of open telemetry. A quick introduction. So I am Shivay. I work as a developer experience engineer at Couchbase, where I primarily build all of our external integrations and also maintain our SDKs as well. And I'm also CNCF ambassador and also Docker captain. And if you want to connect with me on Twitter, you can reach out at Hardware, or you can reach out to me on LinkedIn at Shivay. So we'll just have a quick overview of what we're going to be covering. So the first thing is just giving a very quick primer on what is open telemetry, and then how do you actually deal with these type of high volume transaction systems, and what are the key components that are usually involved, right? Of course, it's not going to be limited to databases and Kafka. There might be some other type of messaging queue systems like RabbitMQ. But what you'll understand today from the architectural perspective can be applied to other type of highly distributable systems where there is a connection to open telemetry. So I just want to kind of kick this off. So this is one of the reports by China and Race in the State of Observability for 2024, which states that more than 80% of different companies are struggling with their monitoring needs. And this
stems down to the fact that there are multiple types of observability platforms or architectures that companies usually employ. And this involves being or basically having a separate monitoring stack for every single one, for every single microservice, or even if you have a monolith, you might have different components involved. Because usually at every large enterprise, there are not just one single subsystem. There are probably 100 different teams that are working on their own systems, and all of these systems have their own, open like observability stacks. So what you end up happening is that when you are trying to understand the overall observability or monitoring of the entire application stack across different teams, it becomes very complicated to maintain all of that. And try to identify that how one team's observability or monitoring that all of their meant, whether the traces or metrics that are coming out, how are they correlated to some other team? Because there might be some correlation between, let's say, if we talk about e-commerce application, there's Guard microservice and there's a inventory microservice. So of course they are correlated with each other, but there are separate teams and separate tech stacks that are being involved for these different microservices. So how do you find out that correlation between the different teams? That is also one of the very important or difficult things to track, especially when you're doing this at scale. So if you look at the traditional monitoring, which is on the left-hand side of the screen, and probably I should move a bit further up. So if you look at the left-hand side, you'll see the traditional monitoring stack, where every single different application is going to be probably having their own logging. They might be having a tracing agent with Jaeger, and they are probably outputting all of this to a Prometheus backend and visualizing all of this on Grafana. So first, you're seeing that we're already using a bunch of different tools for solving every single part of your MELT framework. So for traces, you're using some other tool. For metrics, you're using some other tool, and combining all of them together to finally build your monitoring pipeline. Now, again, you further circumvent this problem when you understand that you're having multiple subsystems. So that is why we had to kind of think of a solution that can unify the collection of all of the different kinds of metrics, logs, traces, spans, and profiling as well under one particular system. And that kind of gave rise to OpenTelemetry. And as we dive deeper into OpenTelemetry, it is one of the most fastest growing tools or basically projects within the entire cloud native computing foundation, basically right after Kubernetes. So what is OpenTelemetry? It is a high quality portable telemetry framework that can collect the different types of telemetry data, whether it's logs, traces, metrics, under one single entity. And then now you can very easily visualize this with the help of tools like Signos, which is an open source tool that can allow you to very easily visualize all of your different telemetry data by storing your data into a database like ClickHouse. And just some stats on OpenTelemetry. So it is, as I mentioned, the second fastest growing project under the CNCF after Kubernetes. And of course, it does not provide you any vendor lock-in. So you can really just have your instrumentation being done for any type of system and leverage the different OpenTelemetry collector with the OLTP, and then also use the SDKs that are available in different languages. So if you're using Golang, Python, JavaScript, there are these SDKs available to you that can automatically do the instrumentation for you and store them inside of your OTel collector, right? And it provides you instrumentation, as mentioned, SDKs for being able to capture all of the different metrics, traces, and logs. And new type of signals like profiling is still being supported. So it's being proactively being added to OpenTelemetry. And this would be kind of your high level overview, right? So you might have a bunch of different microservices where now, of course, every microservice will be delivering the different logs, will be being collected by the OpenTelemetry collector. And now you might now want to actually see these with the help of an observability front end, or of course, you have an APM tool like Signos that can very easily visualize all of your OpenTelemetry collector data by storing it into a real-time time series database like ClickHouse.
And of course, this can be hosted on either some private cloud, public cloud, or even on Kubernetes. Now, of course, the question arises, as I mentioned earlier, that Open Telemetry is providing you a collective overview of being able to store all of these different types of metrics. Right? So if we talk about what are the 6 different pillars of observability, they are traces, events, metrics, profiles, logs, and exceptions. Now, I'll not go too deep into each one of them because that's not the scope of the entire session. But the idea is that whenever you're using any application, a trace would be the span across from one user journey to the entire other, right? So for example, if you're making a DB call, the DB call will, or you're making an API call, that would also involve a DB call. And that would further make call to some other microservice, and finally you'll get the result. So that's an entire trace. Metrics would be just getting to visualize, okay, how quick the response time has been. So these are the different kinds of visualizations or data you want to collect to ensure that your entire application is performing at scale and is always uptime. So these are the building blocks, and you want to be able to collect data for all of these different metrics and ensure that you are proactively always monitoring them. And that is why we need OTel, because it can collectively give you the ability to collect all of them under one single tool rather than using a bunch of different tools for managing all of that. So for example, here with a tool like Signos, which is open source, you could have a list of all of your unified metrics. Similarly, you can look at all of the exceptions that are being raised across your entire application. So whatever type of 404 errors, you can see all of them being visualized because your SDKs are being able to collect all of this data across your entire application stack. And then you can also look at the different logs across the different time frame, because ultimately these are also being collected. You're also getting the timestamp that these particular logs are being generated. And so you can also look at this from a time series perspective, that what are the logs that are being generated over a period of like this, the last 1 hour, 5 hours, 5 days. And then, for example, you'll also get the unified trace. So right from how the user basically starts their journey all the way to the end of that entire trace, you can look at the overall time that it took for every single part of your trace. So you can visualize all of that very easily. So as I mentioned, that Open Telemetry also will be soon announcing support for profiling. So it's still being, of course, it is under the private preview, but soon it will also have the general availability that every single company who is using Open Telemetry can actually use it. And in terms of the adoption of Open Telemetry, so most of the graduated projects within the CNCF, of course, including Kubernetes, have now native support for Open Telemetry. So either it is built in. So for example, if you talk about the pods from a Kubernetes cluster, the pods or the kubelets natively now, or under the Kubernetes API, they natively support emitting logs and traces for Open Telemetry. So you don't have to like have a separate integration. But also if you look at Istio, OPA, all these different CNCF tools now have native support. Or of course, you can add support with the help of the SDKs that you can incorporate in your project. And of course, other CNCF projects are proactively adding support for Open Telemetry. And this is kind of like the standardized way that you will basically collect and unify all of your telemetry. So this particular diagram kind of dives deeper into how the OTel collector actually works. So of course, you'll probably have the different data sources where your application is actually emitting all of your data with the help of an Open Telemetry SDK, or you might probably have a legacy-based application with the help of Jaeger, or you might have Prometheus metrics. So about Open Telemetry is that it does not just work with modern day applications that are using the OTel SDK. If you have legacy applications that were probably using something like Open Tracing, or they might be using something like Jaeger, there are different receivers that are purposely built so that you can also now get your metrics from your existing architectures that were using something like Prometheus, Jaeger. So there are different receivers that can now go ahead and process under the OTel collector, and then it would export it to either a backend system like an OLTP backend, or probably might have some custom backends that can now store all of these metrics that the OTel is collecting for you. So the reason I was basically talking about all of this was that, as you saw, that OpenTelemetry is this one-stop solution that can probably meet all of the observability needs. Now, of course, this is probably a cliche, but of course, some people might not agree that there are some limitations with OTel. And yes, there might be because it is still being adopted. But if you compare it with the existing solutions, it does have a particular niche that it solves. And as I mentioned earlier during the introduction, that why do we need observability for these type of high throughput transactional systems? So as I mentioned that whether it is something like an e-commerce application where there are millions of people coming in and doing transactions at the same time. When it comes to understanding that what is a high throughput or a transactional system basically dealing with, right? There are primarily three different types of application needs that we need to fulfill. Every single transaction that is being made inside of a e-commerce application or a travel booking site, or probably any other example, or another example could be real-time gaming. So real-time gaming basically needs a large amount of data that's basically flowing in. So usually you would be building something like an event-driven architecture or an EDA for real-time gaming or real-time streaming, where your Kafka, so you will have your producer sending a lot of different messages and the consumer would be collecting it after being processed by the Kafka cluster, right? So, basically what you need to have a really stable way of being able to collect all of that data. At the same time, for example, if you want to store your transactions, you might probably need some kind of an in-memory cache. You might not want to store all of your real-time transactions into a traditional SQL or NoSQL data store because that has some added latency, right? So typically, a lot of companies might actually use like an in-memory cache. So I'll give you an example. So LinkedIn uses Couchbase as an in-memory cache for the profile. So whenever you go to the LinkedIn feed or you go to your profile section, your profile data or your feed is already being stored into an in-memory cache so that it can load up very quickly. Or for example, Amadeus is a travel booking platform that serves as a backend for managing the actual booking for companies like Make My Trip, Air India. So they don't build their own booking platforms or the booking service. That's being taken care by Amadeus Labs. So Amadeus also uses an in-memory database like Couchbase as a replacement for Redis, so that you can store your real-time transactions temporarily into the cache. Because of course, when you're reading and writing data from a cache, it is a lot quicker as compared to using a traditional relational database. So whether we talk about using something like Kafka for real-time event streaming or for being able to build an EDA-like platform, or it is using something like a cache, you need to ensure that there is no latency being involved. Because imagine that for some reason your database is running some slower queries that can have a detrimental impact on your real-time data that you're dealing with. So that is why we need to ensure that we can properly trace all of the network requests, all of the DB requests that you're making to ensure that your application is always having a good uptime and it is always quick. So this would be like something like a real-time example where your application has this distributed transaction coordinator. So you'll have some sort of a resource manager where you are needing to have a database, or you might be having a messaging queue, right? If you're using something like a Kafka. Of course, we'll not dive too deep into how distributed systems basically manage the capability of making a transaction or a database transaction and at the same time updating it, because there are different architectures at play. This type of example. This is an example of a two-phase commit to ensure that your database has been properly committed by the active transaction that's happening. So let's talk about the database observability, right? So we want to understand what was the overall query time, what was the resource utilization, what was the overall transaction throughput, because we want to ensure that we are able to very quickly understand an early detection and resolution of things like slow queries. Because if there are slow queries happening, then it can be very detrimental, as I've already mentioned. So here would be an example of an architecture of your entire data pipeline with OpenTelemetry. So you would have receivers from Prometheus, but a lot of databases today, including most of the widely used databases like Postgres, Redis, Couchbase, CouchDB, now have support for being able to export your OpenTelemetry data, right? So OTel data can be exported and it can be collected by the OTel collector. And now you can very easily visualize this with the help of a tool like, Signos. Or if you want to visualize it on your own dashboard, you have that capability. So the reason is that this is what your typical pipeline would look like. And if you look at another architecture, so let's say that you have something like a Couchbase, or for that matter, any other type of database. So your OTel collector would store it into something like, ClickHouse, and then it will run the query service to understand proactively in real time that what is the average query time, what is the average execution time that your database is taking to actually store the transaction data. So all of this will be very necessary when you're trying to ensure that there are no such type of slow queries, because now you are able to visualize that with the help of your Signos dashboard. And in case you see that there are some latency happening in your query or your database, then you can probably go back, look at your entire span network or your entire trace and see what's the hindrance or what's the issue in your architecture of your application that's actually causing the delay. Is it the actual unoptimized SQL query, or it is probably the backend service that's taking time to actually do the SQL transaction? So this can help you to monitor and debug your application more. But let's also look at an alternative approach. As I mentioned, that if your application is also using something like Kafka, of course, your Kafka producer would be responsible for, now first of all, sending your actual data through the producer. And of course, then you create the topics, and these topics are further distributed so that now you can visualize them with the help of your broker. And finally, all of that would be coming to the consumer so that it can consume all of that data that came from the broker. So understanding that, okay, like this is how the architecture of your Kafka application would look like. This is one of the limitations that we currently have with Kafka in general. So Kafka does not basically expose the producer side metrics based on the partitions that are there or the topics that are there within Kafka, right? And there is no active visibility that you directly get within Kafka or with the producer. So native support for being able to debug a Kafka cluster is a bit difficult. And that's due to these type of complexities or the lack of native inbuilt monitoring support within Kafka. And also like the end-to-end latency, right? For example, if you talk about the message broker, how much time did it actually take for an input request from the consumer, from the producer to the consumer? How much time did the producer take to actually emit that particular metric, right? Those are the kind of visualizations or things that we need to keep in mind in order to ensure that your Kafka cluster is always uptime and you're getting those metrics, because these are the type of things that we are actively looking to visualize and ensure that we are getting good results, right? And there is no latency at any point in time during your entire Kafka database. So that is the reason that you would want to basically now connect something like OpenTelemetry. So in this case, if you look at this architecture, right? So you have your external OpenTelemetry collector, and you are going to be now getting the JMX metrics receiver would be looking at all of the different producer metrics. And then as your data is transitioning from the producer into your Kafka broker and being split into the different topics, and the topics are splitting it into the partitions, you're now able to proactively look at the traces and the logs for every single part of your Kafka cluster and have all of that data being sent to the OpenTelemetry collector, so that now you can very easily visualize every different aspect or every different part of your entire OpenTelemetry stack, right? For your Kafka cluster. And this is how your example would look like. So this is your YAML structure that's defining your OpenTelemetry OTel collector YAML file. So here you're defining, the protocols and then the specific Kafka metrics that you want to get, right? So the scrapers would be for the brokers, the consumers and the topics. So these are the ones, your application that will be emitting your logs and traces, and then you can very easily visualize them with this YAML. And here's now going a bit deeper into the specific metrics that you are collecting, whether it's the JMX or for that matter. And this particular example is for a Java application that is running a Kafka cluster. And here would be the exporters. So here you're defining your traces, logs, and metrics, so that now the OTel collector, once it has gone ahead and collected all of that data, how would it actually expose it to something like a Signos dashboard? So that's a typical YAML structure. Now, for a GitHub repository, I'll also quickly show you. So here we have a Kafka OpenTelemetry instrumentation example. So in this case, you'll see that this is the OTel config that we are running. So this is the same, pretty much the same, that we have 3 different brokers in our Kafka cluster. So we are, of course, getting all of the details about each and every different broker and what's going to be the collection interval and what the exporter would basically look like. So if I quickly show you a quick demo of how this would basically now come into picture, let me go to my and run this. So you're seeing that we are pretty much looking at the visualization right now for all of the different things that we're going to be collecting. So whether it's the messaging queue or it's the data of the producer. So in this case, I have a ClickHouse query, which is going to be collecting all of that particular data. And this is my metrics.yaml, which basically tells me the consumer group and all of the data that I'll be collecting that my Kafka cluster would be exporting. So that's just the YAML file that's basically taken care of. And it's also just giving me the service name for my Kafka cluster. So if I proceed a bit further, you'll see that as I will basically run this particular pipeline, and I'll run my ClickHouse query, which will help me to visualize and now view all of the different metrics and logs. As soon as I go ahead and actually run this now, you'll be able to see that here's my Signos dashboard where I'm able to look at my consumer logs and overall metrics such as the resource consumption. All of these are being emitted by my Kafka cluster. So of course, if I go to my traces or my exceptions, I can see where were the requests where, probably my request failed, or probably it took more time for my latency to actually, it took more time, right? So if there is some latency involved with my OpenTelemetry collector, I can very easily visualize that now thanks to OpenTelemetry, and not have to probably have very complex OpenTel or very complex monitoring setup by using different kind of tools, because I can get all of that under one unified architecture with OpenTelemetry. So that is a quick demo of how that would basically look like. And finally, like, this is how your traces would look like. So if you're like, let's say, publishing some kind of topic, you can see the overall time it took. And now, for example, if your next topic is currently in process, you can visualize all of that and go to each and every individual trace and also debug that. So for example, if you want to create automated alerts, you can do that with the help of the Signos dashboard. And ultimately, so what I kind of discovered was that, let's say that if your microservice is the publisher, so it will publish the event broker would now trace all of your messages. But at every single point in time, whether it's the consumer or the broker or your your consumer, all of them are exporting all of these particular melt framework to your OpenTelemetry collector, which is now being used to visualize. And this way, you can proactively look at your high-throughput transaction systems, as I mentioned, which might be using this type of architecture, right? And this is also kind of an example to kind of talk about the EDA part, which is real-time eventing, right? Because a lot of time, real-time eventing platforms like real-time gaming platforms like Buzzy Games, they use Kafka under the hood because they are getting so much data being consumed by the consumer in real time, because they're emitting so much amount of game data at every single second, or probably even every single microsecond. So if you talk probably about a stock platform, that's also going to probably going to be having a similar architecture. So this type of an overview of how you can use OpenTelemetry at scale to connect it with your Kafka cluster is what, a lot of companies are proactively using to be able to get all that metric data. So that is a quick demonstration of what I wanted to convey. But yeah, with that in mind, I'll conclude. And if you have any questions, I'll be more than happy to take them up. Otherwise, I'll be around here. Yeah, thank you. Sorry, you're before. Could you bring the mic closer? Okay, sir. Thank you. So as I showed you earlier, that if you, when you're referring to message broker, you're just talking about Kafka, right? So as I mentioned that in this particular diagram, let me go to that particular slide, which I showed, right? So it's not just limited to your message brokers. Honestly, like you can get any type of data. So for example, earlier, if you had connected your Kafka cluster with a Jaeger receiver, or you were probably using Prometheus to visualize your requests, you can also export that to OpenTelemetry because we have all of these different receivers that are supported by the OTel connector. So it's not just limited to using one type of data structure. You can support different types of data structure. Because a queue would be like, it could be an array-based structure as well, and you can store that. So this could be like a SQS service. If you're using something like an AWS SQS, that would also be supported.
Thank you for taking the session, very useful for us. Just wondering, because typically when we attach an OpenTelemetry, it is basically by microservices. So microservices emit the signal, we attach and producer and consumer. But here you've shown a use case where Kafka, you want to capture the events out of Kafka. Right? So typically, when you attach an OpenTelemetry to Kafka, does it not slow down your, because typically in normal application-based scenario, we attach OpenTelemetry to microservices. Right, and Kafka already have Kafka lenses where we see the actual logs of when the message is being coming to the cluster. Okay, so is that not something that is slowing down?
I think, I guess it's optimized enough because a lot of companies are like, for example, I'll talk about Signos. So I don't work directly with Signos, but I have some good friends there. And a lot of companies are proactively right now using Signos as their platform to visualize their OTel collector metrics. And a lot of companies, I don't exactly know the names, but they are using it specifically with Kafka. As another example is Parsi Games. So Parsi Games is a real-time gaming platform. So when any player logs in and does real-time gaming on their mobile, all of that is being streamed via Kafka. And they're also using OpenTelemetry. So again, I don't have exact metrics of how much slowness might be added if you were not using OpenTelemetry. But what I can say is that in case your system architecture is using, like let's say that databases or microservices, and it's also using Kafka in the architecture, at least you'll be able to now have a unified platform for monitoring all of your because I agree that yes, Kafka will have the lenses, but that's now a separate system. It's trying to unify the overall monitoring stack of the entire company or of the entire infrastructure or the architecture of your entire application, where why people are probably using it. And even if it does probably slow down, it must not be too much, or it must have been optimized enough. Because I've not directly contributed myself to the OpenTelemetry collector for Kafka, but I imagine that it must have been optimized enough that companies are using it in production.
Understood. I think this point makes sense that when you aggregate the whole org want to see everything data in one consolidated way.
Yeah.
I think because the lenses will separate you out.
Exactly. Yeah.
Thank you.
Grafana alone. I've not actually heard of Grafana, but probably have not chatted. Could you describe what it does?
So basically, it is like another OTL connector. So you can connect basis methods and logs. And also profiling data can be sent to pipes to the end systems like Grafana looking.
But is it based on OTel or is it a Grafana stack?
Yeah, it's part of the Grafana stack, but it is doing similar things.
But then companies were not using Grafana.
So taking the time, it was more about open source.
Yes. So I think this is where, if you look at the entire CNCF landscape, there are so many different tools and companies and projects that are trying to do different parts. So it's more about the spec. If you talk about an official observability spec, and OpenTelemetry is probably the largest project that follows the spec. So you could probably have other variants of the spec. Like it's very similar to OCI. Like you have Docker using their own version of OCI, but there might be another OCI for machine learning. So they're using the same underlying spec, but they're implementing it differently. So I think it's more about, yes, if they can be complementary to each other. So what would be better appreciated is that in case the Grafana, what is the name? Alloy, it could probably be complementary to an open telemetry collector. So that in case companies just want to now migrate away from Grafana Alloy or probably want to migrate into Grafana Alloy, if they could be very easily, interchangeable, that would probably make more sense. Because that then is truly, you're not doing any vendor lock-in. Because in CNCF, we want companies to not follow vendor lock-in. Yeah. Telemetry process like that. Could you please repeat the question?
The character side is fine. Yeah, when you send it to the process, has to process the data and push it to the database.
Yeah.
Can be maybe the process, say if I send 10 of data Convin it has and since it's a right thing, we have the number in the process number. Material is the volume of data it can process per second.
Not really. But that's a good question. I can get back to that.
Because when you go to when somebody enables the very high metric enables, that one is cardinally comes into the picture. The most problem comes with the process side, where they basically hang up because too much of data cannot process. Even if I put a in-memory DBs like, yeah, that gets filled up, and I can keep adding on to it.
But if you're probably talking about, again, I don't have an exact metric because I don't work with an end user company. So probably they would be more better suited to answer that kind of question. Because I come from the database background, right, where companies are adopting or using the in-memory database as a mentioned. So exact amount of how much traffic you can handle, that's a very good question. So I don't have an exact answer for that.
And the second one is how the open telemetry handles the cardinal.
Again, probably might have to look into that dynamically as well.
The last one, that's the one. Does it suppose the feature to drop the common logs and the common metric?
Yes,
That is the test. Okay, thanks.
So is it OTL collector become bottleneck for those? So you have one OTL collector which is sending metrics to the end system, then it becomes a bottleneck. And if OTL collector itself is down,
Yeah.
so I will lose all my metrics even though they are available in the system.
No, absolutely.
How do you make sure it is highly available? So is there any architectural pattern you can use for the OTL collector?
Yeah, so I think because you could deploy this on Kubernetes, perhaps similar to how you might have database nodes and the way that you ensure that if one node goes down, you can do like a replica of your database. So you could probably try to follow similar kind of architecture where in case your node basically fails, you could have probably another backup node that can still manage that. Or what I feel is that as if you have like just one single OTel collector, you might probably want to have a distributed architecture where you can have that being supported, not and just one single node is not getting completely logged because of request. Yes. Yes. On the client side. So first of all, this for awareness that earlier OpenTelemetry didn't have standardized semantic convention for different SDKs. So that used to be one of the drawbacks. That, for example, the Java SDK is way ahead in terms of the functionality, but now in terms of the semantic convention, at least all of the SDKs are almost at par for OpenTelemetry. So, but this is on the collection side. That when you are using, like, say, the Java OpenTelemetry SDK, and you integrate it or you incorporate it inside of your database, at that time, whenever, for example, you are making a DB request, and I can probably go into an example here. So Couchbase, tell Java. I'll just quickly show you the code sample for that. So this to kind of show you that usually it's up to the database provider that they will go ahead and create that client so that they can emit those logs. So I think it's probably going to be on the database side that you want to ensure that it can go ahead and maintain that semantic convention. Yeah, exactly. So, like, for example, this is the implementation that we have for the Java client. And similarly, we have a similar implementation for the Golang client. So we are ensuring on that side that yes, it does maintain the semantic convention that are that OpenTelemetry maintains.
I think, guys, if you have any questions, because we are already running out of time. So if you have a question, you can reach out to Shivay.
Yeah, so you can just connect me on LinkedIn. And yeah, my name is Shivay Lamba. I'll just share my name again.
Thank you, Shivay. Have a round of applause for Shivay.
Thank you.
So moving forward with the next talk, navigating the clouds, multi-cluster networking with Istio across multi-cloud, by Imran. So over to you, Shivay.
Hey everyone, thank you so much for being there after lunch as well, because mostly people leaving after lunch and such measures. Thank you so much for being there. And also thank you for being awake as well till now. Right. So yeah. The topic for this presentation is much linked with multi-cloud and multi-cluster as well. Okay, how many of you have been working with Kubernetes? Can I get a cool? Then okay. You guys must definitely love this presentation, I believe. And how many of you have used Istio in production? Good. Thanks. That's good. That's good. Thank you. So, right. So I'll just give a brief of what exactly we're gonna do. Even moving before moving forward, a bit about me. I'm Imran, working as DevOps engineer at Convin, and I'm CNC Kushwaha as well. And apart from being so for those who don't know Kushwaha, basically the one who has completed all the 5 certifications of Kubernetes. And yeah, apart from that, I have a couple of certifications from Google Cloud and AWS as well. And I'm a lead mentor at CERT.io. Yeah. So moving towards the agenda of this talk, so we'll see when we explore multi-cloud, what exactly are the benefits of using multi-cloud and what advantages do we have of having one. And we'll see about service mesh. I already see people who have working with Istio. That's very great. Because those who don't have haven't used Istio, they have a general idea of what exactly Istio does. And yeah, we'll see gateways in Istio. And I have a sample application that I've deployed in the cluster. And we'll see the demo around that. So what this demo basically supports is connecting the two Kubernetes cluster across AWS and GCP. Okay, we dive much deeper into the details as I go through the hands-on. So yeah, right. Exploring multi-cloud. So why multi-cloud in the first place itself, right? Multi-cloud enables organizations to leverage the best out of the respective cloud service providers, right? So each cloud service provider has their own set of services that they are strong for. Like not every cloud excels in every service that is provided. So that's when multi-cloud comes into place, that we enable uh, to bring the best out of each of the cloud and jointly bring our systems up, right? And yeah, what are the benefits of the multi-cloud is basically you can avoid vendor logging. We are not bind to any cloud services. We can move out anytime we want, depending upon the cost usage or the availability of the cloud services as per our use case, right? And second thing, improve resilience and redundancy. Very recently, we have been, seeing of this news is coming up, right? This cloud services, this service, went down for a while. So, right? So this is something very common being in these days, like some recent years. Having a multi-cloud setup definitely helps us to not depend on a single cloud services, but to have it like redundant over multiple cloud services. And third thing, better compliance and data sovereignty. So this is something completely, proprietary to the company data, right? So most of the companies don't want their data to be, out out of their reach. They want their data to be in a particular region, right? So that is something possible to multi-cloud and enhance performance and latency. So depending upon the data centers that are present, right? All of the cloud services they have their data centers in their respective geographical location. So this multi-cloud architecture definitely helps us to kind of route the users which are nearest to the current, nearest data center that's available to that. That is something achievable from multi-cloud. So yeah, that's pretty much about multi-cloud. And yeah, service mesh. So service mesh is like an add-on over Kubernetes that basically gives a dedicated infrastructure layer that manages service-to-service communication and a microservice architecture. Definitely. So if it's Kubernetes, then it's already microservices. And here are the four important part of the service mesh that is responsible. I would say does the heavy lifting instead of us doing the work. So these are the services. I mean, I would say advantages of using service mesh. It takes care of the security, observability, traffic management, and resilience. There are multiple ways of implementing these four concepts, and these are some of the most used, service mesh CLM name called Istio traffic. Istio is something that we'll be seeing, deep dive. We'll see how Istio can we can leverage Istio basically. And yeah, that's pretty much about service mesh. Moving forward to details of Istio. It extends Kubernetes capabilities to go beyond just networking and it gives an application aware network. It helps us to it basically does the heavy lifting part of the network infrastructure and the traffic management. And it operates in two modes. That is one of them being the sidecar mode, and there is the ambient mode. For our current implementation of connecting the clusters across multi-cloud, we'll be using sidecar mode. And what exactly is sidecar again? So it's a container that runs parallel to the workload that you have deployed and adds capability, this capabilities of traffic management and all those security stuff and TLS. These stuffs are completely handled by the sidecar that is deployed by the street. Right. So that's pretty much brief about Istio. Even you can see the diagram is right. So these service and service we are basically the workloads, and you see the proxy, those are the sidecars, which are injected by Istio itself. You don't need to any any heavy complication, you just need to label the workload or the namespace to enable the Istio injection in that particular workload or the namespace. And rest apart, Istio handles the most of it. So use case that I'm going to demo right now. So we'll be having two gateways, Ingress gateway and East-West gateway. So these are basically the core components of Istio. East-West gateway being specific to our use case, that is not country part of Istio, I would say. And Ingress gateway is basically the same as the engine that you guys must have been using in your production clusters, right? So Ingress gateway, as I mentioned, is like it basically allows the external traffic to enter in the cluster. That's pretty common use case of, kind of, I would say, related to Nginx, but much more powerful. And East-West gateway is basically something that enables the service communication from within the cluster to external services running outside. It can be a VM as well and a cluster as well. So cluster is something that I am going to demo right now. So you can see Ingress gateway is something, it's like an entry point for the applications running inside the cluster. And East-West gateway, you can see from there, it is something that is communicating to services that are running outside the cluster. So this is the sample application that I have deployed currently in GKE Google Kubernetes cluster right now. I'll show the I'll show the URL as well. So if you see the traffic that will be coming to the application is through Ingress gateway and through the Istio gateway API. And we have virtual services that are the custom resource of Istio, which are responsible for directing the traffic after it is routed through gateway API. And we have three services. Sorry, three services. The UI service is the name is what it does. The data service that fetches the data from the MongoDB, and image service which is responsible for rendering the image. So these are the three components of this application. So these three are deployed in Google Kubernetes engine, GKE Cluster. And so what I'm going to do is I'll set up the setup part, and I've already done most of it because it's pretty heavy stuff to set up the entire multi-cluster setup. So what happens is you need to kind of configure Istio tell that this is a cluster with GKE cluster to be cluster 1, TKS cluster to be cluster 2. Both of them are on different networks. Okay. And then there are a series of steps that needs to be performed, of which I have written a very detailed article that I'll be sharing with all you guys. You can, type on yourself. Okay. So yeah, these are basically details of the key component. The UI service is in the React and hosted using Nginx. Data service built using FastDK, Python framework. Image service as well. Mongo is the database to store the data, and Minio for object storage of the images. The core components of the application that is running. Right. So yeah, this is the the overall architecture of what is currently set up live is. So if you see, there are two clusters, cluster 1, cluster 2, one being the GKE for now, and cluster 2 being the TKS, right? So Istio is installed in both of the clusters, and if you see this gateway, right, it's talking with the other cluster, that is the East West gateway. Okay, and yeah, and the whole setup is under a single mesh. That is what service mesh basically means, right? And encapsulates the network of the Kubernetes. Right. So there is something even more, let's say, diagram that depicts our current setup. This through each West gateway, the traffic within the cluster is the pods between the clusters are able to talk with each other. You do not need to configure any IP address. The DNS installation will happen with very seamlessly. That is something I felt magical when I did on my own, because I did not have to do any IP mapping or anything. Just suppose there are two instances of a pod 3 if you see. So if I'm getting pod 3 from pod 4, I get so it was basically load balance between the pod running in GKE and TKS. That is something you're going to see live as well. Okay, so that's pretty much the setup. You guys can use your phone and open this application so that I can get some traffic to show you live. So you guys can scan the QR and open an application. It's a very simple application. Like I don't know if you might I'm not a developer, I'm a DevOps person who knows a bit of backend. So UI is something very terrible. Is there with me. Hope you're able to get the application. It's working right. It's an animal album. So just with the some animal photos and all. Right. So what I'm going to do is I'll show you first that I'm going to keep this mic side to be able to show you that. Am I audible to the last? Right, cool. So just to show the demo, I'll be using one of the hands, so I have kept my mic aside. So I have alias two commands, EKS and GKE. Okay. So here, if you see towards my right, I'll be showing you the GKE cluster setup, GKE get nodes. You see, yeah. If you see the name of the nodes are from the GKE, right? They're from GKE. If I do GKE get pods in the animal album namespace, I should be seeing all the right.
So I can see the the components that I mentioned in the presentation, right? Those are running in the GKE cluster. But if I go to EKS cluster, if I do EKS get nodes, just for assurance that I'm using two different clusters and not the same cluster. So you see, it's the naming convention as well, that is called EKS cluster, right? So applications and all the workloads are currently running in GKE cluster. This is EKS cluster. So if I do EKS get for in animal album, won't see anything running up here in EKS cluster. What I'm going to do right now is I'll deploy just one of the component, the image service. Okay, if you remember the architecture diagram, the image service is fetching data from Minio, the images, and is serving to the UI, right? So it has to communicate with Minio in order to send the image to the UI. Right? What I'm going to do is I'm just going to deploy just the image service over here. And what will happen? The traffic that is coming to GKE will go to image service in EKS, and in return, this image service that is responsible for to get the image from Minio will again come to GKE and will serve. So currently, you see the image service logs completely served from GKE as of now. So what I'll do, I'll just open the logs of image service. What seems to be right. So as you remember, there are no workloads in EKS currently, right? So what I'm going to do, I'm just going to deploy it. So these are the manifest files of the image service that I'm going to deploy on EKS, right? There is no traffic in served on EKS as of now. I have deployed the image service in EKS right now. If I go back to the terminal, already started to receive the traffic, and it's let me just scale it then. It's not. No, it's running. I already did the image service live on the EKS cluster. The moment I did, Istio was able to route the traffic from GKE to EKS cluster internally without adding any configuration of IP address and no, I don't know. The country is completely over public internet. How is secure is basically Istio handles that part. So if you go to the setup, right? What I have done in the video article completely, all the details are there. Okay. So Istio uses this called as workload identity, which is basically a service account associated with that particular workload. So a secret is installed on the remote cluster for case it's GKE and for GKE it's case. So both the clusters have their respective secrets, which is getting transferred on each API call between the each gateway. So both the clusters communicating through each gateway. Even if you try to get it from external, you won't be able to get any service because it's authenticated, right? So it's completely handled the issue itself. As part of it, when you install the multi-cluster, right? Both the dock and you install the multi-cluster, that comes as part of the issue itself. It handles the authentication part. Doesn't have to, in order to configure any sort of extra apart from setting up the multi-cluster. Right. So here it's up. So we'll here as well. I'm gonna include the replicas. So we can see already we have traffic coming in GKE cluster. It's not reflecting. Again, let's see. There's a lot of traffic coming here, but I'm not sure why it's not getting presented. Right, it's a bit slow. There's a delay happening. So as of now, we didn't have any workloads in EKS, and we didn't even have, of course, any logs in EKS as well. But if we see the logs in EKS now, so if you guys can go on and refresh the page, you'll see traffic coming from here as well. If there's a delay happening because of the lines are going pretty fast, that's why there's a delay in rendering the logs line. But already. So if you guys are a bit confused how exactly this happened, so I already configured both the clusters as a multi-cluster setup, of which I have written a very detailed article. For the same, I'll be sending in the group itself. Okay, you can see this is already serving traffic from EKS now. Okay. So I have written a very detailed article about setting up this entire multi-cluster and how you can basically set up this entire multi-cluster and have this setup in your production as well. Okay. So apart from this, workload balancing basically between the multi-cluster, how I see this setup as very useful is when you're migrating between clouds. Okay. So most of the time it's basically applying that manifest in the other cloud service and pointing the domain again. So there may be a situation where you come across downtime. Okay. But with this setup, you saw right, the moment I made the workload up in EKS, immediately got the traffic. Right. So we can perform zero downtime migration between clouds if we have this setup in our production. So that is something I believe which is coming out of the box, which is something very magical with all this setup. Okay. So yeah, that's pretty much about this setup. Just I currently did between AWS and Google Cloud. We can even go for Azure. There's absolutely no restrictions of the cloud service at all. Yeah, that's pretty much about setup.
UI service, the base development UI service was having. They did not end up changing their base path. But how did that really work? So what is the base path that the UI service has given? Which they will fetch data from your image service. And why that base path did not change, you to change the whole cluster altogether?
So the entry point of the traffic is still from the GKE itself.
So what the base UI, the image service or the UI service calling to get the image from the
base, the domain is the same. It's still pointing to the IP in the GKE. Base path, I believe, slash images, same one is there. So the base path is it's concerned with the virtual service that is configured in Istio. After that, it is redirected to the Kubernetes service. So everything that is initially talks to Google, yes, and then redirect. Yes. So definitely okay, that's what. So that's what it's load balancing between GKE and EKS cluster. That's why that. Yeah, so I have the exact. Yeah, so currently before the starting to remove this one that converts then I can keep GKE and I will EKS. Yes. If you set up a network that is accessible between both the systems, definitely can. But again, it's the same thing again. If you directly connect both the clusters, then I don't think you can divide issue. And anyways, if you have a private ID which are accessible within both the clusters, then but again, even if you're using something that you won't get if you set up a private network and without this, if you want to configure the same thing, then you need to perform a DNS mapping at each of the microservices. I didn't do any DNS mapping at all. If I can show you the code as well. I haven't done any sort of DNS mapping or anything. Okay, this is still showing me the Minio endpoint as an environment variable. It is basically the internal DNS of Minio itself, and I'm fetching the images from the Minio. Still not showing. Right. So, the thing that you mentioned, sir, about the base path, right? So it's class images and the object and the image ID. That is something data services send to UI, and UI again is calling to this all the list of images. And if I show you the YAML also, you should be able to see. Very good. You see the environment variables for the the menu endpoints is the internal DNS. There's a lot of delay actually. There's a delay happening. So there is a menu endpoint environment variable which basically tells me where the menu is running. Okay, so if you see, it's the internal DNS Kubernetes itself. I did not have to do any heavy lifting of mapping the IP address of what is running in each case. And then it was Istio that was helping me to map this DNS with the IP running in the EKS cluster, the one I just deployed, right? Okay. That's how powerful Istio is, and this entire setup is. Yeah, that's pretty much about this presentation. If you want, you can reach out to me over here. Solve the configuration of that say layman terms, what I'm doing is do counting of details as far sort of access from history of details. So history of details knows the details, the certification details of GKE and vice versa. So the traffic comes to GKE and internally to distribute secret gateway of GKE, goes to secret gateway of details, and then to the internal services. That's how it goes. Not just an extension of this cluster, but basically not everything. Regarding anti-analysis, there is a service. Okay, so one more thing, just missed about mentioning. So you need to create an empty service of Minio in EKS, because or else EKS won't be able to generate that DNS. So there is this service in if you see there is service named Minio in EKS cluster, which won't be having any endpoint. Okay. If you guys know about Kubernetes, basically every service has its respective endpoint, which is basically the IP address of the pod. But if I show you the endpoint of the Minio service, which is basically required for this setup, it won't be having any endpoint, it's none. So once the DNS is registered, the mapping of DNS with the IP address of the pod running other cluster is responsible. The one is still responsible for doing that. So you need to create an empty service, basically, have the label letters of the same pod. You see that there is no endpoint for that service, but that service is needed because the DNS resolution needs to, it initiates from Kubernetes, but once it's initiated, then after it's taken over by Istio and it maps the IP address and it's running the remote cluster. Okay. Any other questions?
If services are running in GKS and it matters to the customer. The same services are running in two sides. Need to pay for two minutes. It's pay for 2 letters to Kubernetes. One down, it won't need it the particular GKE target. If you need enough of one down, then you don't need it the particular. And after one, GKE just a GKE system, GKE image service system. How it read it is
If I completely bring down all the parts of image service in GKE, it will all the traffic pages. Because
If it down, if it down. If image service in the GKE,
I got it.
is down, then how it will read it GKE.
So that is what is happening, right? If load balance is giving a service of image service, the processing both GKE and GKE. So if the point is unhealthy, there is no traffic able to receive here. It will collect all the traffic pages.
You said what should be the mean?
No, post bin there. Because initially they were not working on GKE also, right? The moment I made it up, went all the time. Even if you want, I can bring down the image service in GKE, it's still an application exists.
The task is differently.
That is some, okay, so use case matters a lot. By reason of presenting this is something, a possibility of what you can set up. Suppose you are doing a migration from EK to GKE, definitely you can leverage this. So please go down the incantation cluster, right? You can once eventually start migrating to a cluster, you bring this cluster down eventually, and you change the domain mapping down. You have zero down the migration. Any questions? Thanks.
The round of applause for Shivay. I think we are already running out of time. So moving forward to the last part of the day. General pitfalls and their solutions. Like data engineering on Kubernetes, general pitfalls and their solutions. Vice Chair Shankar Prasad. So over to you, Shiv.
Really, what's the past? And I expect people sitting on the last row to forgive me. And if you don't listen, I might take it for an hour also. So, and obviously, I like the people sitting in the last bench, so the questions will be for you. Okay, so my topic was for data engineering on Kubernetes. Okay, and when they approached me, I said, okay, I'll give you a lightning talk. But yesterday I started creating my PPT, and I understood that lightning really stuck me. Where I understood data engineering is a very complex, wide topic. Giving a lightning talk on data engineering and these challenges are going to be challenging for me. So I thought either I can go into the deep technology of it, or I'll just go the high level of it, and then cover as simple as possible, the most widely used tools as possible. And then maybe later we'll have a deep dive session. But for now, since mine is just a lightning talk, I'll just focus on the widely used open source tools that we have. Okay. Again, there are a lot of features that I might not be covering. There are a lot of features that a vendor tool or the tools in the market might cover. But for now, to keep it simple, I'm just going with the basics and basic mistakes that people do while using Kubernetes, right? So why do we go to Kubernetes? Again, my slide is now in PPT, a lot of animations and stuff that I added are not going to be coming up. So I'll be asking questions, okay, to cover that up. So why do we usually go to Kubernetes? Scaling, one is good, scaling. Stability, okay. How do we achieve stability on an application with Kubernetes? Okay, so the downtime is less. Latency, how do you achieve latency is a question of concern. Latency is high, okay. And what are the other things that we do? Why do we go cloud native? High throughput, okay. I'll come to you later with the coming slides. Quicker deployment, that is great. Yeah, somebody was saying something else. Okay, so to use the capabilities of cloud, again, I'll circle back to my original question. What are the capabilities? Okay, forget it. Since it is lightning, I'll go lightning fast. Okay, so there's a lot of features that you get from Kubernetes that makes your deployment faster, highly scalable, high throughput. I'll come to you.
And it makes things much easier, but it also makes things much complex as well, right? So data engineering as such, if you know, data engineering mostly is stateful. What is stateful? What is stateless? The guy on white shirt in the last row. All three are your white. So what is stateful and what is stateless? So somebody here says you store the data, it is stateful. If you don't store it is stateless. In a way, it is correct. But a layman like me, I'll say, if it knows the state, it is stateful. It doesn't know, it is stateless. So what do you mean by state then? It knows its state, meaning what it is doing, it stores it somewhere, like as you said, right? Somewhere it keeps the memory of what it is doing. And then say, for example, you go to a market, you buy apple, and then you walk away. The shopkeeper is stateful. He knows that you purchased apple, but did not pay. You are stateless. You don't want to bother about it. Right. So stateful applications remember the memory between the interactions that it performs, right? Data engineering as such, mostly is stateful. And Kubernetes was designed, at least initially, for services which are stateless. Kubernetes favors services which are stateless, although now it has a lot of features that support statefulness, but Kubernetes as a design, as for a layman, is a stateless application or a orchestrator. So the general pitfalls that we have, right, with going into Kubernetes for data engineering is that you will end up having challenges where your call flow is stateful and Kubernetes managing it is going to be tough, right? This is not me. That guy is little better looking than me. Okay, so as I said, I've taken a very basic set of tools that we all know, right? Today I get a requirement from the customer. Customer says, hey, I have data which is kind of semi-structured, mixed structured, like this Lego process. And I also have data which is continuous, like your tap water. The data keeps flowing. Customer says, okay, I have these are my data sets. And then I turn back to my developer and I ask my developer, okay, write a code for this. These are the stages that are needed. So my developer goes to obviously where ChatGPT and makes my question as a prompt. And ChatGPT says, oh, this is great, right? ChatGPT for some reason loves Python so much, right? So now ChatGPT gives you a code. You write a Python code which pulls this data, right? And then process it using pandas. I don't know. People lately, developers are loving this pandas more than the Chinese pandas, right? So lately, this pandas is so popular. So what happens? You write a code, your code becomes, your code works without any issue, flawless, paka. You thank ChatGPT, but don't pay it, but be happy with it. And then you write code. Okay, you come back to me saying, okay, I have written my code. Now it is able to take the data from the customer's data sources. I am able to use it. Now what happens? I tell them, okay, for streaming data, use some database that handles time series, right? So they go through all. See again, I'm saying I've just put few tools here. If you list the tools, I can write tools up to a couple of kilometers. So I say, okay, use some tool that can do transformation. Meaning, what is the data transformation? You have varied sources, you have various metrics in it, you just take it, parse it, and make it meaningful, right? So time series database, people go often with a lot of tools. I put OpenSearch here, which is good at doing time series aggregations and stuff. So one data goes to OpenSearch via my pandas. The other one, people use Spark, do all the Spark aggregations and stuff. And finally, they dump into any database. I put two databases. One is PostgreSQL, which is for relational data. The other one is OpenSearch. Again, it's for time series data. And things that are not in this slide, which are on that white side of the screen, are machine learning, Presto, As I said, white, this is also turned white. I think this one, oh yeah. So after this is done, data analytics, lakehouse, everything happens, Presto happens, everything happens, right? So what happens now? Your code works. Now customer is happy, you are happy, you party, and next day, Monday morning, you move to production. Customer was talking about this. Customer was pumping huge data. Customer was dumping data in lorries. Now your Python script fails, right? Python you wrote was very happy to be handling small data, and then now it fails. Okay? Now you are a developer. What you'll do, you go to your architect or your lead. Your lead says, I am a development architect. Go to Kubernetes architect. He will help you. Okay, now you run to the Kubernetes architect. Kubernetes architect says, no problem, chill out. We'll do replica set, autoscaler, everything solved, high data throughput. So now you hear good news from the cloud architect or your Kubernetes architect. Come back, modify your deployment file, add replica set as per your base, and then you expect magic to happen. Will it happen? It will not happen. Why? So I've taken AI images for superhuman and superwoman for replica set and autoscaler. So now what happens? You try autoscaler. Okay. Again, this was having an animation, but let us see. Let us consider you have one pod running. You expect your autoscaler to kick in 3 more pods, but it takes its own sweet time. Why? There are a couple of reasons. One reason would be you as a developer are feature eager, which means on your Python script, you would have written a lot of requirements. Pandas, NumPy, uncle, auntie, next street boy, all on your requirements file because you are feature eager. When you write a code, what you think? This will be needed. It's like our old uncle storing everything from European times on his own thinking, sometime this will be useful. That's what the developer do. As you're increasing your requirements file, the Docker pod that you create is going to be heavy. An autoscaler, when it starts a pod, has to start this entire image. And then when you're, so again, here, right, this topic. If it is like this, it is okay. If it is like this, it's okay. But what happens in real production is, it changes from this to this, right? Sometimes it is small running water, all of a sudden pumps it. Sometimes it is small chunks of data, all of a sudden GBs of data. That's how production setups are, burst traffics, right? For a burst traffic, when you want to auto scale your system, autoscaler will try to bring your pods up. Pods are heavy, what will happen? It will take time. And in most cases, the cycles are seconds, right? If your pod takes seconds to start up, what will happen? Your data gets dropped, right? So now you are in a glitch where you have put autoscaler, but still your data is getting lost. Throughput is still not achieved. You will be thinking, why did I say it? Okay. BPS will help you in doing what? Yes, correct. But the pod has to load. Where will it load? Will you keep the pods running without load? So ideally it works, but what I am trying to convey here is it's the responsibility at the development stage where you make things better. Don't depend on the Kubernetes expert to come and fix it for you. Right? And okay, so now the autoscaler is a problem. As he says, the developer changes his code. By design, he puts replica set as 3. Right? Now he comes back to office, happy mode, thinking his pod will work, his application is great. But 99% what happens is one pod runs, rest 2 just waits. Because on your code, you are happy that I will stay with strong confidence that most of you would have written tf.read_CSV. You load a pandas data frame, happily thinking pandas is your overall god, will take care of everything. Right? Now what happens? one pandas instance runs, read CSV, to sit and watch. Right? You're wasting your resources. So now again you circle back to your lead asking, I did autoscaler, I did replica set, nothing is working. There is a very high chance that your lead might say, get out of pandas, start using something better, like Dask. Right? Dask, your lead will say, hey, that has parallelism and all that stuff. But Dask can do parallelism only within the container where it is living. Even then, it will have the same problem. Right? So what you need to do is, while you're writing your Python code, focus towards parallelism right at the way you test the data. Right? You test the data and start parallelism right away. So what you did, you went and did all research. Somebody said Python is heavy. You select some other language, right? So now comes a language called as Rust, which is also open source, which can do the same set of work that your Python can do, but Rust is in a way better. How? Anybody can say? Memory efficient. Okay. How is it memory efficient is a second question. I'll come back. So, what is an interpreted language? Any college student? Compiled language, interpreted language. If you don't raise hands, I will raise my. Yeah, please. Yeah. So an interpreted language interprets your code right at the runtime, but a compiled language builds all the logics during your build cycle, and when it runs, it will just run as a compiled mission level language, right? So Rust is a compiled language, like Presto going to C++ from Java, right? They are converting it more focused towards mission than to the upper layers, right? See, since the advent of Kubernetes, one thing we all should understand is it has taken away the dependency of OS. Like earlier, 10 years back, 20 years back, one code you develop for Windows, Linux, Unix, all flavors. Today, you don't bother. The production application, you only focus upon the pod, the image that you're going to use, develop for it, it runs everywhere. Kubernetes takes care. So write your code on a sleekier programming language like Rust. And again, it has a very tough learning curve, but I don't bother. So write about it and then make sure you use the components that makes it faster, right? Okay, so this is again an example of how you should write your Docker file. Again, it is too technical, but not too technical. Technical for people who have not seen it. See, this Docker file has stages. If anyone have heard about stages in creating your Docker file, yeah, please go. You can stand and
Basically kind of landscape, which will make the image size smaller for after deployment, like I was space in the registry, which is DDR or GCR or AWS PCI. And basically the first stage what you do is you have few steps and the bindings you work along daily. I think the next section. Can is things and complete the build and in second stage we will use the bindings with the first stage we use the second section and then the rest of the evidence. So the main reason what we do is to have a size.
Thank you. So, as he said, when you have multi-stage, you get rid of a lot of garbage on your code, right? You have a lot of files that you will have when you're building the Docker image. So, focus on building multi-stage images. And see, I'll tell you this example. The first image without multi-stage was somewhere around 1.2 GB. Again, I had all that on my machine bucket. So the first image was somewhere around 1.2 GB, but after you do it multi-stage, it was somewhere around 250 MB. So the lesser the image size of your pod, the quicker it is going to start, right? So while building the image, a developer should also understand how sleeker this pod is going to be, right? You need to be aware. See, again, this is one challenge that we see on all industries. Developer is totally ignorant about Kubernetes complexities or Kubernetes features. Kubernetes admin is least bothered about what the developer is doing. And the end product, both of them are going to support. Nobody will bother. Okay, so again, you build it over REST, data bursts happen. Again, you go back to your lead, same old story. He says, put Kafka, right? We have seen Kafka here, right? Now, what is the challenge? Kafka can do wonders, but Kafka also has its own limitations. I've seen people who do Kafka configurations using deployment cells, replica sets, and all that stuff. However, I'll tell you, most of these already have their orchestrators. What is a Kubernetes? Kubernetes is an orchestration engine, which says, hey, these are the workers, these are the managers, and all that stuff. Most of these tools, Spark, Kafka, OpenSearch, whatever you think, Presto, everybody has their own orchestrators. Do not create your own deployment files, stateful sets, and all to handle these. So these have their own operators. Use them. They will take care of putting the proper configurations for you on Kubernetes. Okay. One problem that I have seen, people putting Kafka on Kubernetes and complaining that the producer is not able to reach the broker is not able to reach, receiver is not able to reach the broker, because there's a lot of complexities inside it, right? See, Kafka is stateful, right? Kafka needs to write data to disk. Kafka has DNS, IP endpoints, static endpoints, and all. So you cannot manage it using your own stateful sets or your own deployments. Use relevant operators that will facilitate your flow. Okay. Again, the same thing will go to Spark. As seems people putting Spark deployments where they, again, I don't understand why people have such a craze towards putting replica set numbers, right? I see people putting in replica set 3. What it will do? It will run 3 times. What these 3 pods will do? I don't bother. My architect told, as a developer, make sure your pods are all having replica sets. What will that do? It will do something. It will run 2 pods. Okay. So the problem with all this Spark and all this stuff, I've seen people putting in, what is a Spark driver? I'll again go back to the same old cloud, which is looking like a odd constellation for me, which is people are all, they're seeing all directions. So what are the components inside Spark? I believe somebody took a session in the morning, right? So at least that time you were not sleeping. What is the Spark architecture? What are the components? Forget about architecture. What are the components inside Spark? Yes, please. Yeah. So driver, cluster manager, and workers. What does the driver do? What does the worker do?
So the driver mostly goes runtime environment and all of the things that Spark needs to run. Cluster manager handles the worker execution and task scheduling, and workers are the actual nodes which run the tasks.
Thank you. So drivers are basically driving the workers to do the work. And I have seen people putting replicas at 3 for drivers. Will it do any better? No, workers are the ones which needs proper scaling, right? And worker scaling, you cannot do it with your own autoscaler. A Spark operator has to do it automatically. So these are main problems that I see because of the gap between a Kubernetes expert and a development expert. This is nothing to do with one person's expertise, but the domains are totally different, but they have to work together. That's a primary challenge that we see everywhere. Okay, so since mine should have been a lightning talk, somewhere when the lightning struck me, I became a little slower, so forget it. So focus towards parallelization right at the code level, okay? And use proper tools, right? There is a tool called as Ray, which is becoming popular now for data engineering and MLOps. Use that. You have Spark, which can do data aggregations and stuff. And one other critical mistake I see, people run both Spark and OpenSearch, and they do the aggregation that OpenSearch can do on Spark. Give it to the expert. OpenSearch can do a lot of time series based aggregation. Let it do that. Spark, let it do only the aggregation functions that Spark is good at, right? And for self-orchestrated clusters like Spark, this is what I said, right? For Spark, OpenSearch, and they all have their own operators. Please use that instead of doing your own configurations, right? Okay, and again, another problem. I've seen people just using an NFS as a storage layer underneath, and then they believe we have a production setup. NFS is very cruel when it comes to Kubernetes. If NFS fails, your weekend is gone. So properly select the storage layer, understand how things are. Okay, I would like to ask a question here. Okay. Anybody who has used PostgreSQL here? Have you used it on Kubernetes? One guy took his hand but he was scared. I will go to the next question. Okay. What would be the challenge of running PostgreSQL on Kubernetes? Or any relational database in that context? So relational databases are stateful. One problem. Second thing, they don't have multi-master kind of a setup, right? Like open servers are things, they have their own orchestrator, they have worker nodes working. Mostly relational databases have a master and a replica cluster and one person serves at a time. And if your pod restarts, gone. So natively, relational databases they're not designed to be a proper system for Kubernetes. But lately things have changed. So there's a tool for PostgreSQL that you could use on Kubernetes that can get rid of this challenge. What would that be? Anybody knows that name? Because I already shared it on the slide. So you are three are the ones who are listening to me. So there's a tool called as PG Bouncer, okay, which can run alongside your PostgreSQL DB as a sidecar, and it takes care of the statefulness of it. I'm not going into the depths of it. I'm just saying when you have a relational database, you might need a sidecar which helps you on maintaining the stateful set. Now, NoSQL databases already have an orchestrator and they are already distributed. Okay. Okay. So, any other question? Yeah. So, focus on data engineering needs high throughput. Part of them are in memory. Part of them are disk-based. Kappa is disk-based. Spark is in memory. So, I've seen people designing Spark pods with very low limits, or they safely ignore both limits and requests. They don't want to give it because they don't know it. So if you that's one again a major problem that I see with developers, because again of the domain difference. When a developer creates a deployment, he tries to safely ignore the request and limit, thinking Kubernetes will take care. Kubernetes is not efficient in taking care of your pod allocation if proper request and limit is not given. Okay, that's a mandatory requirement for your cluster to work well. And as we force them to give it, what they give, very low request, very high limit. That is also dangerous to your Kubernetes cluster. Okay, so you need to run it on your dev or staging, understand the metrics, use observability correctly, put proper values, and make sure you have proper efficiency coming out of Kubernetes. So that is all I have. Hope I was quick. Lightning. Finally, I didn't come to you. You are happy. Any questions from the people who are searching something? Any questions? So either it means I was super clear or you never bothered.
Again, a big round of applause for Shivash. At least it was a bit lightning, right? Okay. Thank you, Shiva. So Anand have some announcements to make. So final quiz time. Okay. Ready for some swags, right? So I think Anand have a lot of things to share with you guys, right? I hope you heard about Presto clearly at the time of Shakyan. If not, then you are going to pay for that at the time of quiz. Okay. So yeah. Buckle up, guys. Why you are so sleepy? You didn't had chocolate cake. Yeah. Right. So I just request you, sorry, sugar. Oh, sugar is spiking. Oh my God. So I think you to take care of the traffic, just run up and go to home, right? No need to take the Uber. Okay. पहली स्टेप पे चलने के लिए नहीं सर पकड़ नहीं Okay, guys. So you have to scan a QR code first. So we'll give you a time of 2 minutes. Just take out your phones, right, and scan a QR code. Just a second. नहीं कुछ नहीं this page, right? नहीं अभी तक नहीं है slides here.
So guys, finally quiz time. So hopefully you are waiting for so long and you have attended all the sessions. So yeah, here's the QR.
Please scan this QR because if you will delay it, then you will not get the opportunity
And
to scan it.
this quiz is fast and finger first. So like you will get 15-second timer or 30-second timer. So it doesn't mean you have to answer in 30 seconds. Just those who have answered like just starting of the timer, their leaderboard will be get pop-up. And some people have like just asked like they have not scanned the QR for the coupon code for getting enrolled in the certification or a Kubernetes certification. So you can just count like after the quiz, you can just get the QR. And we are also distributing the lucky winner prize. There is in month we host something called lucky winner stage 100% coupon code offer. So when people those who got in a lucky draw, they got 100%. Like they don't have to pay to the Linux Foundation for the certification. They will get 100% off. So that will be like lucky winner contest we host per month.
Oh, 1 minute. Share the screen. Or maybe turn on the camera and point to this. I think that would be better.
Yeah. So all of scan. So if everybody is set up and like get through this first question, so we'll pay that. Guys, those who have not joined yet, please join. We'll wait for 2 minutes. After that, we'll start the first question. I think everyone already inside this quiz panel and back. Okay, so let's move to the first question. Such a great response, I think. Leaderboard,
This is okay. You can.
Anyone have any issues?
It's my questions.
Taking some of the questions are correct.
Yeah, actually, my speaking is not. So it's not, there's all the person.
Time.
Next question, no special. Go to next question, someone not available.
Start. And you go. How many of people can get the question back?
Might be one copy, something.
Now it is coming, right? Oh. I'll show the leaderboard. So moving forward with the next question. And top three leaderboard people will get Core Cloud subscription for 6 months, so it's completely free. So if you can go and get a realm about the cloud native ecosystem, and and four positions, they will get a book like Kubernetes Bible book and Dancing book. And we have slides for everyone. So please participate. These all questions set by the today's speakers. So we are not responsible for this. If you don't know it, or if you have missed this particular session. We are already at the half of the quiz. I कौन कर रहा है? So now we have last question. So already you can see the leaderboard. And last question will decide like who is the first, second, third, and fourth. So such a great response, guys, and sorry all negative any between. Yeah, so Anup, Manya, and Hari Krishnan. So have a round of applause for these 5 folks, guys, top 5. I'd like to call like Anup, Manya, and Hari Krishnan. Yeah, we really need your credentials, like your email to sending you the subscription. And Lokesh and Atharva, like where are you guys? So for you, we have.
You can only give the book.
Yeah. So Lokesh.
That thing go there and take these things. Okay, Lokesh.
Yeah. Yeah. Just.
Call Sachin to give the book to
Atharva. So Maya and Krishna, you just provide him your name and
Get the 4 o'clock premium.
So how's the event, guys? Just be louder so really we can hear you. How is the event, guys? Yeah. So like as like last meetup was getting postponed until we haven't received any update from Google side because that venue was Google. So still we are in a phase of planning the second meetup, but and we have already planned the next meetup because when once we are hosting the meetup, we already have the bumper meetup for the next month. So we are doing meetup on 31st week, right? Yeah, so 31st May is the date we are hosting next meetup. So you keep checking the LinkedIn page or meetup page. We after this meetup or 1 or 2 days later, we'll post that event on meetup. But registration will be not open as like once the meetup will like once the event will get listed, it will be open just nearer to the event. So keep. Yeah, so open. Yeah, so every day is like from tomorrow or day after tomorrow, the registrations will be open for the next meetup. And like in June, we are planning something big. We can't reveal it now, but we have something we are planning big. And we will post you and update you on LinkedIn page as well as on meetup page. And we really need your feedback. So please share your feedback so we can improve or wherever you find like we need to do something which supposed to be done for your betterment or like community betterment. So
please feel free to share your feedback. And yeah, like as a genre for Meetup, at last we generally ask like if anybody is hiring here or
Yeah, hi everyone. So basically, you can give the feedback here. So if you see any scope where we can improve, just let us know. Or also, not only that, you can join our WhatsApp community where you can reach directly to us. Be it about the Meetup, CFPs, whatever or not, you can put the message there. And it's a general discussion community. You can discuss about Kubernetes, AI. If you have any job openings, you can get help from others. So also I would suggest you to join the community. So this WhatsApp group is there. And apart from that, whoever participated in the quiz, right, will distribute some small swags that are there, some stickers and notebooks are there. So once you guys here, if someone is hiring among you, you'll pass on the mic, just let us know. So you can, the community can benefit on that. Let us know and we'll reach out to him. And after that, we'll call out the names whoever participated in the quiz according to the order, and everyone will get some swags. Yeah, that's it.
So if anybody is hiring or if their company is hiring or they can give reference for the role. So if anybody is hiring.
And